So first of all, I really want to thank all of you, because even during this very special and tough period, we got a lot of reaction from all of you. I got 125 registration, and to give some numbers, I had, maybe Julien, you can remind me how many people from the different countries? Okay, yeah. So we got 63 registration from Belgium, as well from Flanders, then from Wallonia, 26 from Germany, 32 from the Netherlands, 3 from France, 1 from Luxembourg, 2 from Austria, and 3 from Switzerland. So I really thank this very good and common participation from all countries. We are here in the context of the E-TEST project. You know, we just organized the kickoff a few weeks ago, but we are here specifically to focus on the advisory board and on the Einstein Telescope advisory board. So this is a joint event between the E-TEST project and the ETpathfinder project. So I want to stress it, this is more general. And this is the agenda we will go through today. First of all, you all received the link. I hope it's okay for everybody now. You received 2 links. The first link, the Zoom one, will be used for all the general common session, for all the prototype sessions. So if you are participating to the prototype, you just stay online, and for the closing. For the one who are interested to attend the geology session, we will give you time to connect to the second Zoom link, and then you will attend 2 hours of specific geology session. And at the end, at noon, we all come back in this session for a closing, for a common closing. So I hope it's okay for all of you. And well, I will start by, no, I'm sorry, I went a little bit too fast. What I want to talk about is, first of all, the Einstein Telescope project in general and the ESFRI Call timeline. Then I will do a very brief 2 slides presentation of E-TEST, ETpathfinder, and the under submission project ET2SMEs. I will explain to you the purpose of this industrial advisory board, to who it is dedicated, what are the conditions to participate. We will show you the ongoing and future E-TEST and ETpathfinder procurements. We will say a word about the key enabling technologies, and then about our online catalog of ET technologies. Then you have the 2 parallel sessions. Then the 2 scientific lead partners, Christophe Colette and Frédéric Nguyen, will do a summary of the main point, the most important point you will have noticed during your session. We will talk about the next step altogether and the upcoming procurement and events. So I will start by giving the floor to Professor Christophe Colette, who is the Director of Precision Mechatronics Laboratory at the University of Liège, and who is the E-TEST scientific lead partner of the prototype part. And Christophe will explain us why, first big question, why do we need an Einstein telescope, Christophe? So,
yeah, thank you very much, Annick. So can you hear me well? Yeah?
Yes.
All right. So good morning, everyone. Thank you very much for joining this event. That's really great. So I'm not going to to review the scientific case for ET in details, but maybe just wanted to start with a brief introduction. So the Einstein Telescope is a gravitational wave detector, and gravitational waves are these periodic deformation of space-time when we are in presence of strong astronomical events like merging of black holes, for example, approaching at a speed which is close to the speed of light, and space is like going to be deformed in a wavy shape like you see on the slide, as it was predicted by the theory of general relativity of Einstein a bit more than a century ago. So that's really impressive. And but just to give you a flavor of the magnitude of these waves, so we are talking about relative displacement of 10 to the minus 18 meter for 2 points which are separated by 1 kilometer from each other. So we are talking about super tiny quantities, and maybe Einstein was probably far from thinking that we were one day being capable to make this detection. The technology. So Annie, can you go on the next slide, please? Yeah. So many instruments have been developed for developing the technology for pushing it to a sensitivity which is sufficient for being capable to make these detections. A number of observatories have been developed all over the world. So the pictures that you see are like the most sensitive one. They are working under the principle of Michelson interferometer. So they have these two arms, so are perpendicular to each other, and the beam, which is going out of the laser, is like divided into two parts, each of them being reflected and then recombined in case there is a relative variation of the length of these two arms. So a signal is going to be detected on the photodiode. So that's for the basic principle. And maybe just to give you an idea of how it works. So on the next slide, you will see a video showing a reconstruction of the first event that has been directly detected by this gravitational wave detector. So you see these two black points are black holes merging and creating these waves, which are going to propagate all over the place in the universe. And when these waves are going to reach the Earth, so the Earth is going to be deformed, but of course with a super small quantity. And when these waves are passing, through the detector, they are going to fluctuate the length of the two arms of this Michelson interferometer, like you see here on the video. And this fluctuation will create in turn a signal light which is fluctuating and detected on the photodiode of the detector. So now that is a reality, many detections have been made, and so we have now entered in the new area where we are say reporting all these events in a catalog. So of course now everybody is convinced that this is a technology. I mean, this is in which we have to continue to invest in the future, and that's the reason why the Einstein Telescope has been say initiated for preparing the future. So on the next slide you see you see a sketch of what is the Einstein Telescope. So we are talking about a huge triangle with each which is like 10 kilometers. So each side has 10 kilometers is 10 kilometers long. It is expected to be at about 200 meters deep in the ground for finding a quiet place for many reasons. And we are also talking about an instrument which is going to be at cryogenic temperature. On the next slide, you see some numbers. So you see that it's not one interferometer that we will have, but several interferometer in this like folded arrangement. It's expected to be 10 times more sensitive than the current instrument, which means that we will make much more detection than the current instrument. And Yeah, so we are talking about an instrument which is going to be like a long-term observatory. So uh, on the next slide, you see some more information about the context. So this Einstein Telescope will be a long-term infrastructure. We are talking about the an operation for tens of years, maybe 50 years or so. That is going to be upgraded, but it is also going to be built on existing, I mean, technology that we will continue to push in many directions. So we are here today to review a little bit what are the directions that have to be pushed forward in order to reach the design sensitivity of this Einstein telescope. So the impact of this Einstein telescope on the next slide, please, Anik. Yeah, is expected to be huge. So we are talking about a lot of opportunity for the industry, and this is the reason why we are here today. We are also, of course, talking about a large scientific impact, and we are also talking about, of course, a lot of job uh, to be created in many different fields for this during the construction and operation of this telescope. So these say economical impact have been detailed in uh, two documents which are available for those of you interested in knowing more about the different impact that this instrument might have. But of course, before this, this impact will be huge if the telescope becomes a reality. And so there is something I like to, there's a diagram I like to show on the next slide, yeah, which is showing the different project of particle colliders. So I'm not talking about gravitational wave detector. Can you maybe mute your microphone, Anik? Or there's a big echo in. Okay, I don't know where it comes from. Okay. Yeah, so this diagram that you see is not about gravitational wave detector, but of course, a similar one could be done for gravitational wave detector. It's about particle collider. And so each vertical line that you see represent one particle collider, and the different colors are representing the different phase of the project. The pink one is for R&D, then there is the project is approved, and then we are building the instrument, operating, this is the green part, and then decommissioning phase at the end. So until like 30, 40 years ago, after just a couple of years of research and development, we could start building the instrument. Now, it's not the case anymore, and you see that the pink part is exploding completely. So why is it like that? It's because the technology is not ready. And so, among other reasons. And so in order to remain this instrument affordable from a financial point of view and from time, say, scale point of view, so we have to work hand in hand with the industry and make as much as possible uh, uh, a transpose the technology from one application to another one. And this is completely true, of course, also for the field of gravitational wave detector. So we have to build on existing technology. We have to push it in many directions, but we should not reinvent everything. And so it's, I think, giving some clear evidence that we have to work hand in hand with the industry to make this Einstein telescope reality, become reality. So that's it for this short introduction. Thank you very much. Anik, maybe I give you the floor for continuing.
Thank you very much, Christophe. Yes, indeed, this graphic is really the reason why we are all here today, because we are a lot of already scientists working in different projects to have this Einstein Telescope implemented in Euregio Meuse-Rhine, but without the companies, well, I think we won't make it. So this is really a great ecosystem that we need to build. And so for the one who just arrived right now, so I'm Annick Pierrard. I'm the senior manager at the Interface Entreprise University of Liège. I'm busy with Interreg project management, and I'm the E-TEST project coordinator, general coordinators. I'm not doing the scientific coordination. And I think I will now go through different, shortly to different projects. First, of course, it is the Einstein Telescope. Christophe explained to you the reasons why we want to build this. And I think from my side, the most important thing to show you is the ESFRI Call timeline. In fact, you know that the application for the Einstein Telescope has been submitted here in 2020 in this ESFRI Call. We are two competitors. You have the Euregio Meuse-Rhine region, and you have Italy with the site in Sardinia. So in 2021, ESFRI will decide about the roadmap. In between time, you know that the two sites are in competition, but they have time to deliver their bid, but it will include all the realization. And we will take into account the realization of the ETPathfinder project, who started last year already, the E-TEST project, and I hope a third project who will also deliver some good results. And the decision, I mean, the final date to decide this will be in 2023, maybe beginning 2024. The very, very final decision when all this is submitted is in 2025. So then we can start preparing and building the Einstein Telescope in 2026 and 2028, I think, for the building. And then in 2024 and 34 and 35, we will start exploiting the Einstein Telescope. So this timeline is extremely important for us and for the industrial, because you will see when we are able and when we need the collaboration with you, because we are here in the phase of preparatory projects. Then here we will be in the phase of building the telescope and then in exploiting the telescope. So as I explained, the Einstein Telescope is a project that will be carried out within the framework of the European Strategy Forum for Research Infrastructure, so ESFRI. There is a governance of this telescope. For the moment, it is mainly led by the NICEF, and there will be a decision for the final governance. And you must know that each region has somebody representing the country and the region in this governance. And the total budget is extremely huge because it represents 2 billion euro. So this timeline, please keep it in mind, and also for the two parallel sessions, because you know then when companies are involved. So I want to now go through the different ongoing projects. The first project that was launched is an Interreg Vlaanderen-Nederland project, and it's ETPathfinder. ETPathfinder is an R&D lab for future gravitational waves detector. It started mid-2019 and will go through 2022, maybe with 6 extra months due to the COVID, I don't know. And its budget is 14.5 million euro for instrument and building only, so no personal cost in this. And this is the consortium of this project. And you will see that NICEV, University of Maastricht, and KU Leuven are also part of the ETPathfinder, of the E-TEST project, sorry. So we are really collaborating a lot because partners are in the different projects. This is the timing, the budget, and I really invite you to go on this website to find all information about ETPathfinder. So what is it exactly, ETPathfinder? It's really the construction of a long-term infrastructure for testing future gravitational wave detector technologies and concept in a complete interferometer within a ET-like environment. It is built at the University of Maastricht. It's really a full interferometer. It's just like a part of the Einstein Telescope in small, but exactly what it will be in the Einstein Telescope. And the arms will be of 20 meters each. It's expected to be operational for decades, and the configuration may still vary. And the mirror can be cooled to 120 Kelvin in the first step, and in the second phase, maybe also at 10 Kelvin, just like in E-TEST. The clean room is planned to be ready in 2021, and ETPathfinder fully operational in 2022. So you see, we stick in the timeline, in the ESFRI timeline. Then we have the E-TEST project. That's an Interreg Euregio Meuse-Rhine project submitted in the Call 5, who started on the 1st of February of this year, so only 10 months ago, and who will finish mid-2023. It's also a 15 million euro, and it's divided in 2 parts. E-TEST, you will see here the consortium. It's 11 partners coordinated by the University of Liège, and you will find again some existing partners of ETPathfinder and of course some new partners that are coming from Germany, Flanders, and the Netherlands. So E-TEST is a very important step for the Einstein Telescope because it's really a proof of concept of both the prototype side and the geological side. And that's a really specific part of E-TEST. E-TEST will build a prototype. So it's really a large suspended mirror at cryogenic temperature, 10 Kelvin, so very close to the absolute zero, to validate the Einstein Telescope technology. And this is completely unique. It has never been done. E-TEST will also run an underground study to map and to model the geology of the Euregio Meuse-Rhine. It's a complete study. It's not only drilling, it's also the complete modeling of it. So this will allow to define the optimal design of the prototype and of the location in the ground of the future Einstein Telescope within the Euregio Meuse-Rhine. So here I did a summary of the 4 working package. The first part, so the prototype side, contains 2 working packages. One is focusing on the ultra-cold vibration control, and the other one on the optical engineering. We have here the latest picture of the E-TEST prototype with there is 8 partners if we count University of Liège one time, and there is 9 partners because you have 2 different departments involved from the university, the CSL and the PML departments, Fraunhofer, RWTH Aachen, U Hasselt, UC Louvain, KU Leuven, NICEV, and University of Maastricht. The key feeders of this prototype is really the low frequency systemic isolation system. It's full scale, so it's not a reduction, it's really built full scale of what it will be in reality and combine active and passive. And it's really a large cryogenic mirror, so meets the Einstein Telescope seismic isolation requirements. So here I will show you, I'm very proud to show you a small animation of this. So I will unshare my screen and I will show you a small animation that a student, Eloise of Christophe Colette, did in a very short time. Do you see my screen? Yes. So yeah, you have this beautiful animation of the Einstein project. Then you have a focus on our prototype. You can see the different part and composition of it. This suspended mirror. And here, sorry, it's of course, it's silicon without an E, sorry, it's of course, it's silicium mirror. And it's maintained at cryogenic temperature. So you see, there are two prototypes for the moment in competition. We have two ideas of prototype and it's not decided yet. These are the dimensions of the inner chamber and the outside beside of a human being. And this is in the red, where it will be localized in the complete Einstein Telescope. This prototype will be developed at the CSL. And here you see, of course, the funding that allowed us to realize this prototype, the financiers and the partner of the E-TEST project. So thank you, Eloise, for this great animation. I will go back to my presentation. Okay. And then you have the second part, because E-TEST is really divided in two completely different parts. Oh, sorry. Yes, voila. And in this second part, you also have two different working packages. The first one is really focusing on building an EMR cross-border underground observatory. And the second is the geological modeling and engineering geology of the Einstein Telescope. And if I have to summarize in one very nice picture, and thank you, Florian Wellman, for this great work, we can show you the 3D geomodeling. You see the land surface, you see the relevant default, you see the unit boundaries. And so you will have this underground laboratory, and you will have all this 3D modeling to determine the position of relevant geological feeder. And it's really combining all the data that we will be able to define the really best place of this Einstein telescope. You know that it's a big triangle, and it will be localized on the border between the Netherlands, Belgium, and Germany. So this is our consortium. This E-TEST project is led by the University of Liège. And for the communication, I just want to say many thanks to NMWP, who is almost working full-time with me. And you have 4 different scientific lead partners at the University of Liège. The department of Christophe Colette, the one of Frédéric Nguyen, of Hans Balder, and also the CSL with Jérôme Loïc. You have the 4 working package I was talking to, with every time ahead of this working package, because we are really collaborating and each partner is leading one of these working package. So we are really in a collaborative and Euregional project here. And that's not all. This is the scientific part of it. But we also have this industrial advisory board led by the project partners, but involving directly all the SMEs, other companies, business development agencies, sectorial agencies, networks of companies, cluster of competitiveness, and also local, regional authorities that are really involved in the development of this Einstein telescope. This is our timeline. You see that we only started with E-TEST on the 1st of February 2020, 10 months ago, and 1.5 months after. we had to stay at home with the virus. So it was a tough start, but still all the scientists have been working a lot to progress anyway, despite of this situation. So we have two projects running, and I just want to summarize the differences. You have ETPathfinder, who is this R&D lab, so a small Einstein Telescope built in Maastricht, complete interferometer, dedicated for science and industry. And then you have the E-TEST with all these geological studies, the unique subsurface studies. It's only here that it will be realized, and this underground R&D lab. Then the prototype proof of concept. So this prototype will be realized in very hard condition, at cryogenic condition, at 10 Kelvin. And of course, all the results can be used to develop and test new product and gain new insight and knowledge. These are the differences between the two projects, but this is also why we are together. We have two projects, but we have a unique goal. It's the implementation of the Einstein Telescope in the Euregio Meuse-Rhine. We have one unique timeline in our head. It is one of the ESFRI Call. And we are joining efforts in research and development, in innovation, in communication, in collaboration with companies. And we have built this joint industrial advisory board. So we have the two projects. We have a specific COMAC to follow ours. We have this joint industrial advisory board, and we have a third project in submission. And even if it's in submission, I want to say a word about it because it is directly involving companies. This project, it's ET to SMEs. It has been submitted in the call 6 of Interreg in Axis 1 Innovation, and it's an umbrella project. The objective is really to maximize the social and economic impact of the implementation of ET in the extended Euregio Meuse-Rhine. We submitted the final version of it a few weeks ago, the 10th of November 2020. We are waiting for an official decision from January, so it will come very, very soon. And the project could start, if accepted, on the 1st of March for 2 years and a half. We have a budget of 2.3 million euro. We are covering the 4 regions, and not only the core region of the EMR, but the extended EMR. And we have a voucher envelope of exactly 900,000 euro dedicated to SMEs that will be financed at 50% by ERDF funding. So the company will have to bring the second half of it. We have this partner involved, so it's more business development agency, and it's really covering much more this industrial side of the project that is a little bit missing in ETPathfinder and E-TEST because we are much more scientific. So you have the POM Limburg involved, the Interface University of Liège, so I'm involving both projects, Skywin, that is our pole of competitiveness, Sowalfin, the LEOF in the Netherlands. This project will be coordinated by AGIT and also involve NMWP. We have associated partner. I'm sorry, maybe this list is not fully complete. We have the great pleasure to have also sectorial companies who are covering the one country, 2 region, and the different countries. And we have also letters of intent from partners that are very precious for us. So you see that this is involving all the economic and financial partners in the Euregio Meuse-Rhine. This is divided in 4 activities, a very professional mapping of all the companies, and it's really for free. We will map you, and you will have an additional publicity of your company, what you are developing and your expertise. We will do really company visits. We will have company fishes. So the need and the expertise and technologies of each company will be analyzed and see how you can match together and collaborate with us. Then we will develop this financing cooperation. we will help you with vouchers, vouchers from 25,000 euro up to 50,000 euro. So we can deliver up to 18 vouchers to SMEs. And the criteria to apply is that at least one of the company is an SME from the Euregio Meuse-Rhine and can collaborate with another SMEs or with a big company or with research centers. So you will have the detail of all the criteria as soon as the project is accepted. And then we have a working package focusing on the long term, because we want this industrial advisory board to live and exist and collaborate much more longer after the end of this project, up to the building and working of the Einstein Telescope. So you see, there is really a cross-border value chain for innovation in this project, with a first step of mapping, then this active business development support, because giving money is not enough. You need to really to create an ecosystem with these companies. Then we will give you attractive fundings to help developing your innovation. And then we will make this industrial advisory board sustainable. So it's under submission. You know, I'm still crossing since the submission already. I hope the result will come soon. I just want to say a few words about our communication. Please don't hesitate to go on our website that is really built and running since May already, because you have a lot of information dedicated to company on this website. It will be updated with the procurements. So the activities and the online catalog of the Einstein technologies. We will communicate with you through this website, but through also this biannual industrial advisory boards. We will participate to big event as soon as we can. We wanted to be at the Präcisiebörse, but it was cancelled, unfortunately, end of this year. And this will depend on the sanitary situation. We will also do campaign of communication to the society, because we have the communication with companies, but it's also involving, you know, the places, the communities, the village where this Einstein telescope will be localized. We will communicate via LinkedIn, Facebook, and Twitter, and we will also organize very specific workshops dedicated to companies. So please go on our website, because it's really full of information about our activity, mainly dedicated to industry, about our general ecosystem. All the news are published, and you also have the complete information about all partners and expertise of these partners. So please don't hesitate to contact partners from your country if you are feeling more comfortable with it. Then I come to this very important things. It's why are we here and the purpose of this advisory board. This is the very first one. It's a joint one. And the purpose is a real collaboration and direct interaction with all of you. So with the industry all along the E-TEST and ETpathfinder projects, and up to the ET building and exploitation, because we don't want to just present you our result. We want an interaction, because what we are planning to do is not existing. As Christophe said, the technologies are not existing yet. We need to challenge you, and you need to show us what can you develop with existing technology to fit the need of the Einstein Telescope. So the targeted participants are all the SMEs or big companies active in the field of the Einstein Telescope, as well for the prototype than the geology. The business development agency, because you are in contact with all the companies in this field. The sectorial agencies, because you have this big network. The clusters of competitiveness, and it's mainly this in Wallonia, and also the local regional authorities. So the politicians, the administration of our governments who are fully involved in the Einstein Telescope development. So this first meeting, we are explaining everything without any non-disclosure agreement. But of course, you can imagine once we will go deeper in the detail, we will prepare a mutual non-disclosure agreement to protect everything you say about your technologies. So this is in preparation at the University of Liège, because in E-TEST we have a partnership agreement. The University of Liège will do it in the name of the consortium, because you know we all have existing knowledge at the start of the project and it belongs to the consortium. And if we want to be able to talk and communicate freely, we also need to ensure the non-disclosure of this property. So there will be a very deep follow-up of all the procurement procedure, the tendering of all partners, and a publication via the usual channel, you know, the public market department, and also on the websites. And we will write and publish an online catalog of Einstein Telescope technologies. We are at the beginning of it. And for sure, I think we will have to build it with you, because we need also your expertise, the companies of the companies, to build this catalog. And I propose we organize the second Industrial Advisory Board in 6 months. So in May, end May, beginning June, at your best convenience, I will do a doodle for that. So we keep a 2 times a year timing. It's not too close. We can have every time new result to present to you, and it's not too long. We don't wait 1 year because maybe too many things are happening. So to this day, I want to inform you that there was already a first tendering about the vacuum vessels published by the ET-Pathfinder project. This is the link. I don't know if it's still possible to apply for it, but I wanted to mention it. And for E-TEST, we have this tendering in preparation, and the first one that will be published will be about electric tomography. It will be published this Monday, on the 14th of December, by the team of Frédéric Nguyen, and it will be published via the usual channel and on the website. On the page industry, you will see there is a subpart procurements, and it will be present there. So please go on the website and have regularly a look on it, because a lot of important information will be present. I also wanted to mention this because you all know the key enabling technologies. Never forget that this group of 6 technologies have been defined in Europe and by the governments to be the very 6 important group of technology to focus on. So micro and nano electronics, nanotechnology, industrial biotechnology, advanced material, photonics, advanced manufacturing technologies. So these fields are extremely important to innovate in. So we really expect an increase of industrial innovation to really address the societal challenges of today, and there are many, many, and create advanced and sustainable, more than ever, today we all know it, economies. So we are starting to create this online catalog of ET technologies. You can already see on the E-TEST website these technologies that have been identified. This one are dedicated to the prototype, this one for the geology side. And for each of these technologies, we will build a page with a description, a picture, a summary, the state of the art of this technology, and also the challenge we are expecting from companies that should be developed to be able to build the Einstein Telescope. So I don't know the time. I'm fitting in the timing. And I think this is it for the general presentation. Before going to the two different sessions, I first would like to give you the opportunity to ask questions. So does some of you have any question? You can unmute your microphone, raise your hand and talk. Is it clear for all of you? I will now explain how we will proceed. For all the people that are interested to attend the Interactive Industrial Scientist prototype session, please stay connected with this Zoom link. It will be led by the E-TEST prototype scientific working group. It's led by Christophe Colette, who is the scientific lead partner, and it's organized jointly with the ETpathfinder partners who are present today. And it's based on the Einstein Telescope requested technologies. So the basis of our discussion will be the catalog of ET technologies. What we need, what you have, what is the challenge, how can we collaborate together? So you will be split it in two. So it's about, let's say, 50%. We are not so much. I really invite you to not to hesitate to put your to raise your hand, put your micro and camera on, and have direct discussion all along in this session. And not only write, you can use the chat, of course, because then we can see maybe when somebody is talking, you have an idea and you just write it, but don't hesitate to participate because we really want a very interactive discussion and with you. So I don't know if I will maybe go through the chat to see if there is a question. I saw, yeah, there is some remarks from some companies because they're specialized at very deep temperature and a very high temperature. Alors, to be clear, there is one industrial advisory board for the two projects. Yes, there will be one industrial advisory board because we are really addressing to the same companies, and also because the prototype side is the same for both projects. So not to duplicate and not to multiply all these meetings, we found it much more constructive to have this joint advisory board. And don't worry, you will have this PowerPoint, you will have all this meeting is registered, and I will send you the link to all the participants, and it will also be published on our website. Yes, thank you, René. Associated partner for ET2 SMEs is Photon Delta and Brainport Development. So we have also associated partners, very close, who will closely work with us in the new ET2 SMEs project. And thank you, Christian. We will be on the Belgian pavilion, Big Science. Yeah, hopefully. And I really hope we will be physically there. The deadline for the ETpathfinder tendering is January 8th. So please, if you are a company who could submit a tender, please, it is still open, and we really invite all of you to have a look to this tender. I will, yeah, we will share the link of this tender. I will ask maybe Julien to share the link of the tender in the chat. And Frédéric said yes, and the one for Monday too. Oh, but Stéphane did it. Oops, sorry. Yeah. a common format between Agoria and E-TEST for the okay. Of course, Christian. If you already have a competencies inventory, we are more than, yeah, we of course we will collaborate. This is very constructive. Sorry to be late. Yes, sorry, Christophe, and I'm sorry also because I wanted to say that I've been badly ill with COVID after our kickoff meeting, and I've been really knocked out for 3 weeks. And I know that I invited you at short notice, and I'm sorry for that. And that's why I'm very happy of all the attendance we have today. And I know that for some of you, it was too short notice, but we will send you all the registration of this, of the record of this meeting. And thank you for your interest. Thanks anyway for your interest. So I've been through the general chat, and I propose that now we separate the meeting in two. So all the companies and all people interested to attend the geology session should now connect to the Zoom link number 2 that I have sent you per email. Maybe I will put it, yes. I will put, right, I will stop sharing this. I'll go in my email and I will show you the link.
So, okay, good morning again, everyone. Yeah, let's start this this session about the instrument part. This is not a presentation, so the idea was to review together a little bit what are the different challenges that we will have to face for developing or validating the technology for ET. And so I don't know, Anik, I'm not sure I have the same version as the one you have on your. So okay, so you start with that one. Then the thing is that, as you understood from the introduction of Anik, so here we are, talking about ET, and we have now two large Interreg project running and developing and validating the technology. So it's amazing if you think what was the situation 2-3 years ago. There was like not so not so many activity in for ET, and now we are through these two projects. We are like building a super strong community of scientists and also industrials involved in the technology. So this ET train started and it's running quite fast, I would say. So I'm not going to remind what is ET, what is ETPathfinder. I don't think it's really relevant. So I think maybe you can pass this slide, and yeah. So I think we could go a little bit further because all these things we discussed already. So we will have, so we have identified a number of technologies in that we are going to discuss together. But so the list is here. So cryogenics, vacuum, precision mechanics and mechatronics, metrology, optics, mirror, coatings, lasers, controlled stuff. This is a little bit arbitrary. Okay, so to this, we can list much more technology here, but so what we will do is to give you a kind of example of what are the technology we have to develop together. Yeah, Nick, so I think you can already continue. We will not show again everything about the prototype and so on. Yeah, so I don't know if we want to make a kind of tour of what are the different industry connected in this call. What I did here is that I have prepared for each of these topics, I have prepared an example of challenge that we are facing, and I have also listed a number of, say, expression of interest from different companies. So, for example, here, so if we start with the first one about cryogenics, so what are, I mean, what do we have to do, and that has not been developed in the past, is to cool down a super large mirror, which is going to be suspended by long fibers. So this has been done for much smaller mirror, but when it comes to large mirror, then many new problems are coming. So there are people much more specialists than me in these fields who could comment more on that. But I have here listed 3 companies. I'm sorry if some more companies have expressed their interest in this technology. But yeah, the list I have used, the list of registrants I have used, is not the latest one. So here we see that Resam Engineering has expressed an interest. Axilon, RI Research Instrument from Germany. So I would be, I mean, the idea is that these industrials are maybe commenting a little bit on what is their field of activity and how they see their involvement in the in this yeah Einstein Telescope work.
Yes, so if I can add something, please don't hesitate to put your camera on, to put your micro on. Only 3 companies have been listed, but we are 60 participants. And I really propose that all companies that could be interested in the cryogeny, really, please express yourself. And all the partners, also the scientific partners from E-TEST and ETpathfinder, please take part of this discussion. Maybe explain where we are, the state of the art of this technology, the challenges that are expected for to get this Einstein Telescope up and running. Allô, allô?
Oui.
Mr. Quitman?
Yeah, are you interested in a 30-second presentation by the companies, or?
Yes, you can present. You can use a presentation from your own. You can.
No, I don't have a presentation, but Research Instruments is very interested in this project, and I think we have quite some experience that is relevant. We work with a lot of big research institutes like CERN or ITER. For cryogenics, we work a lot in ultra-high vacuum, for example, in extreme ultraviolet lithography with ASML or ZEISS, where we also do a lot of precision mechanics, big optical elements, very high tolerant or very small tolerances on alignment and stability. And I think we have something to bring to the table for the ET project and would be excited to become part of it in some sort. That's it.
Thanks a lot, Christoph. Sounds great, yeah. So
your mic is
yes,
off.
but we don't hear you.
Sorry. Yeah, Xavier, I see you just connected.
Yeah, so we're not listed, but so Amos is also used to produce cryogenic solution or cooling solution. Now there is a lot of people in cryogenic. What we can also handle here is also the thermal shrouds and what is also around actually the system to cool it inside the chamber. In terms of cryogenic, we used to do that for other applications, as you know. So in the space sector mostly. So indeed, we have know-how there that can be also used and applied.
Mm-hmm. So there is an additional company here that we can list. And
Amos is listed for other.
yeah.
Yeah, I know we have several scope of competence, but one is suspected.
Good morning, everybody. My name is
Hello.
Ronald Dekker from DEMACO in the Netherlands. I would like to express our interest in the cryogenics and high vacuum systems as well. DEMACO is a company working already over 35 years for scientific institutes worldwide, and we are fully specialized in the cryogenic infrastructure for helium, nitrogen, etc. And we are very interested in cooperation with the ETpathfinder and the E-TEST prototype project.
And so for all the companies, you see here we do an industrial advisory board. You are all present, and what do you think? Which form should we use to have a very, very intense collaboration with you, discussion? How would you organize it to fit the best to your need of a company? What do you expect from us to be? You know, this is the very first meeting we are organizing. We are involving all the scientists, we are involving all the companies, but how would you see in the future our way of collaborating with you? What's the best? Do you want smaller workshop? Do you want smaller groups? Do you want to divide, for instance, per technology, all the working groups? How would you see it? Hello?
I think to get an overview of the technical challenges, which I assume are, there's a lot of them and they're very different. Some of them are purely mechanics, some of them are purely optic, some of them are mixed. We still need a better understanding of your work breakdown structure or the work packages where you have need for involvement of industry. So that would be the technical question. What is it that you need? Which technical solution? The other question that will be coming up is how's the financial model? How is your funding situation? Will you order development projects from companies, or are you making a call for proposals? Or
there will be two things. We will do call for tenders. In the call for tenders, it is not joint call for tenders. One partner is doing a call. We cannot do joint call for tenders in Interreg. And when you answer to a call for tender, you are financed at 100%. It's the total money of the tender. But of course, we must be extremely transparent, and this will be European call for tenders. It's open to everybody. We have to respect the competitiveness of the companies, and there will be no priority. If you are in the advisory board or not, it doesn't give you a priority. The big advantage of being in this advisory board is that you will have very regular informations about the progress of our project. But we will have to analyze the tenders and to choose the best of the best company. regarding the price, regarding his expertise, the one answering the best, the one challenging the more. And so this is one way to collaborate with us. It's through the tenders. Then, as I explained to you, we submitted a new project. In this project, after doing a mapping and a company questionnaire, we will be able to offer vouchers for companies to collaborate and to innovate in these technologies. So in this case, you receive 50% of the research. So the voucher will be funded by FEDER and you receive 50% of the money. If you are doing some research, for instance, for 50,000 euro, you receive 25,000 from us. So it's financed at 50%. When you participate to the advisory board, it's for free. It's a free exchange from us to you, from you to us. We can't pay industrial to participate to the advisory board because very honestly, it's a real win-win to my opinion. And also we don't have budget to pay the companies to participate. We hope that what it will bring to you will be really good and very positive for the company itself. You know, you will be aware and you will be part of this timeline and you will have time to plan your pipeline, you know, to plan the short-term, mid-term focus by collaborating with us and to be ready when there will be the big call for tenders of the Einstein Telescope. So we hope that we can really help you innovating during these coming years. So this is the way we can collaborate. And also with the catalog of online technologies, because there is the state of the art and then there is a challenge. And the challenge, we can define it with you.
Aniek?
Yes?
I think Marco Beyersberg here co-sign. We are more in optics and cryogenics, but you asked a question on what is required to work together. And I think the previous question was also a little bit about that. Your focus and talk has been a lot about procuring products. Will there also be fully funded, 100% funded development projects? Because the suggestion is a bit that the R&D is either co-funded by the companies or is done by the institutes, and that only the companies will only get 100% funded for procurement of existing products. Will that remain the case, or will you be able to do more like an ESA model where we can also get 100% funding for developing new technologies based on the capabilities that the companies have?
No, we don't have budget for this in E-TEST, and I think not in ETpathfinder neither. Can somebody, maybe Stéphane or Franck?
Yeah, I can say a few words. So in ETpathfinder, we have these 14.5 million purely for equipment. But really, this is kind of not for R&D development, but really more or less for buying materials and buying the parts. Okay, so obviously there's quite a lot of things in there where you have kind of off-the-shelf components when it comes to vacuum pumps and so on, but there's no R&D in there. For the vacuum vessel, there's a little bit more R&D in there because one of the things we are trying to really is to get down the water contents to avoid freezing on the mirror. So there's a little bit in the tender which you could classify as a little bit of R&D in there. But in general, that's a big problem. So obviously in these research projects, we don't have kind of millions to fund the R&D at companies. Either we have to do it ourselves. Ideally, we do it together. And for that, the voucher scheme is very good. Maybe we can find other ways of, starting up with some pockets of seed funding here and there, or even write grants together. But unfortunately, we are not in the situation that out of these 14.5 million, we say, okay, and we have 10 million that we can give away for things to be developed.
Yes, thank you.
To answer your question about Aniek, about what is required for a good collaboration, I think a certain level of funding for the companies to actually develop, so for example, like in the ESA case, that is really required for a good collaboration.
Yeah,
Yes,
Nick?
yeah, that's why we submitted ET to SMEs, who is really covering much more this industrial part with vouchers, but it's at 50%. So as in E-TEST and ETpathfinder, there was not this funding possibilities of the company only through the tenders. That's why we developed ET to SMEs. As soon as we have the approval of this project, it will come really soon in January, February, we will have it, yes or not, and we will start on the 1st of March. And from that moment, we will be able to deliver vouchers. So this is really somewhere you can apply and at least get 25,000 up to 50,000 euro. And this will finance R&D. This will finance innovation for the SMEs. Yeah.
And Nick, may I add some reflections on this? As an ITER ILO and colleagues internationally are aware of this, indeed, I join fully the comment of Marco in the sense that it is of utmost importance that there is a good interface between the science world and the industry world, and that this interface is being made in due time, meaning if the science world is developing concepts up to the point of starting the call for tender, then the problem may arise that all the questions will come during the tendering phase. So if the science community wishes to be aware in due time of the potential challenges, one way to collect this kind of problems is if you organize, for example, for each lot of specific technologies, for example, the cryogenics, if you organize a kind of market survey, in a way that allows you to find all the competences and skills oriented to, for example, the cryogenics world, then during this survey, or this survey is accompanied by a kind of information session by the scientists, which means that they expand the present status of development, the present, like you see here, for example, on this cryogenics drawing, you see drawings there, so that means that somebody has been developing something. And so he expands how he has developed this and why, these drawings, and to make aware up to which point everything is clear. What comes then during this session with the people for a specific technology topic, like cryogenics, they will ask questions. And during that kind of discussion, there might be things coming on the surface which the scientist people were not aware of, because these questions could be about, okay, how do you intend to make this or that component leak tight, or whatever. There might be a lot of questions raised, and that will give an idea about the level of maturity of the development, and that will then allow the scientist part to detect which parts should be submitted for further development before going up to a tender phase. So a smart way from the organizer point of view is to try to collect the open gaps in the development until now. So by expanding what is the status today, getting questions from the audience on that specific team, and then afterwards treating the gaps by saying, okay, we need definitely a further development on this or that topic, and then it can be organized either by a system of voucher, where you're talking about, in order to cover some more exploration work, or kind of small pre-study or whatsoever. but it is very important that challenges are detected. So I mean, from the industrial point of view, that they are detected in due time before you launch the call for tender phase, because otherwise you may end up with a lot of open questions.
I understand. Yes, Stefan?
Maybe I can make a point here about, just to make sure, I guess it's clear for everybody, but just not to mix up these different tenders, because we're talking about these three different things. We talk about ET, which is kind of the 2 billion tech. We talk about ETpathfinder and E-TEST. Okay, so let's start with the big one. In ET, I think we will start, you know, for the big tenders, for the cryogenics and the vacuum and things like that, to go out, you know, in a couple from years, more like 6 or 8 years from now. Okay, we're talking about 2028, 2026, and so on. Okay, so these are far away, and as soon as we have the ESFRI status, and I think so that should happen in about 1 year from now or so, there will be a preparatory phase, and in this preparatory phase, I think it's currently planned to be about having about 180 million in there. Okay, and that I think is where you know, we are going beyond the peanuts, as someone mentioned the term in the window, and go beyond this, and there will be money really to go for the, you know, all of the standard schemes that you refer to ESA and CERN and things like this, where there's really real money to say, with well-defined interfaces and projects, this is, you know, what we want to build in order to, you know, understand how the tender then for the, you know, for the 200 million or whatever system should go like. Okay, so in order to prepare us for all of this, yeah, coming back for this ET, what comes then in over, you know, in 5 years or so from now, we said, okay, what can we do? What can we do to get, you know, everything off the ground and, you know, not avoid all of the mistakes that you say by getting the industry too late in, but, you know, how can we start this process? And that's where really kind of, you know, 2 or 3 years ago, we said, okay, for that we need something like ETpathfinder and E-TEST, which are obviously much smaller. You know, they're a percent or something in the scale of the Einstein Telescope, just to learn, just to build up the collaborations, just to have exactly the discussions we have right now, that we are talking and, you know, getting to know each other and things like that. Okay, so it's a completely different level what we are talking about for E-TEST and ETpathfinder. Still, I think it's a super useful. It's an essential. You know, without this step, we couldn't get there. So here it's slightly different. Okay, and in these ones, we really kind of, you know, we need to learn from the scientist side. We need, you know, we have a certain possibility to collaborate with industry, but obviously in a completely different scale, and especially when it comes to, you know, how much money we can invest into companies for R&D, that's a completely different scale than what will be there in a few years from now. Just to set the context.
Yes, you are fully right, and that's why I want to tell you, we are in the preparatory phase. We are in preparatory projects, and I think informing all the companies right now of what's possible with E-TEST, we are really in time, and that's why I insist on this timeline, you know. And for us, I mean, for the E-TEST project, which just started in February, the 1st, and we have no tendering yet. The first one will only be on Monday, and really, I wanted to do this advisory board as soon as possible after the kickoff, because, you know, it was a very tough start for our project with the pandemic situation, but we wanted to do it so that all of you are aware of what we are doing. And this catalog of technology is in fact a catalog of the challenges. So this is really what you are saying, Christian. We want to work jointly with the companies to build this catalog and the need, and to define the need, and it will really also help you to write our tenders, just like you say, maybe much more efficiently. And we are still nowhere. We are the very first one. We are only 10 months behind us. And that's really why I'm insisting on this catalog of technology. I'm insisting of the tender, and I'm insisting of having this joint advisory board every 2 times a year, and to do it jointly, so we don't duplicate and miss some companies. We just pool everybody and we give the same information and we progress all together. So you see, this tendering for ETpathfinder is still open, and it's still very, very new. For this one, of course, it's published already, but there will be many others. So we want to work with you. We don't want to do everything in our corner. And that's really the purpose of this meeting today.
Yeah, and I agree with Stefan that there is difference in scale of anything, meaning budgets for exploration, for engineering studies, etc. That is very clear to me. But on the other hand, a pilot installation has also a primary purpose to check some of the fundamental concepts and principles, and that means that. In particular, a pilot plant has a more crucial role in detecting things because exactly when the problem arises on the big industrial scale, then it will cost much more. So the pilot plant development allows exactly to put all the questions on the table and to see, okay, this is a point which needs much more deeper investigation when we want to build this at a large scale, for example. So it is not only, let's say, solving all the issues which will rise, but at least making an inventory as big as possible in order to be aware this is a kind of things which in the later phase must be investigated, and we need this or this amount of money to put in the later phase, otherwise we will run into the wall. So a pilot plant has definitely a very important role in that.
Yes. Yeah. Okay. Yes, Christophe.
Are you working with technology readiness levels or some sort of assessment where you need further development on the different components in your big system? I mean, here we only see cryogenics. Do you have more slides and challenges? Maybe we should go through.
Of course. We have, you know, there is this complete list. I will show you. We will go, sorry, we will, attends, where am I? Wait, because we will go through all this list. Sorry, you see?
Yeah.
We were the first one.
Okay.
So don't worry. It's because I wanted the company involved in cryogenics to be able to express themselves, and also to hear really the need of companies, because we are not willing to do something that is not fitting for the companies. So we should take some time to really understand very well. So now I propose that we go to the second technology, Christophe.
Yeah,
oh,
why
sorry,
not? But
sorry. Oh, sorry. I'm sorry. Attends, I'm. Yeah, my mouse is.
No, but maybe first I wanted to ask around if there is any other company who wanted to introduce itself on the cryogenic side before we switch on with the next one.
Yes, we like to know who is there, who is interested. Don't be shy. Huh? You put your camera on. We are in a small group. So it seems.
Yeah. So then let's continue with the second example of technology that we need. So this is about vacuum, and so just again to give some example of challenges. So you have seen in the sketch of ET that there are a lot of huge towers. An example is shown on the slide where you see this is the tower of the one existing tower in the Virgo detector located in Pisa in Italy. But what we will need for Einstein Telescope is many towers much higher than the one existing. So we will need also something like 120 kilometers of ultra vacuum pipe. And so we are talking about pressure down to 10 to the minus 10 millibars, so extremely challenging. So that's another example of technology that we have to develop. So in a similar way, from the list of registrants, I just extracted some example of company interested in vacuum. Aperam is one. Amos is here now. Research instrument again. So I don't know if they want to present themselves and comment a little bit on that. The floor is yours.
Christophe Kay, Aperam. Can you hear me?
Yes, absolutely. Very well.
Okay, thank you for giving me
Good morning.
the opportunity to speak. Good morning. So in fact, I was hesitating also to speak about cryogenics, but let's say that globally, Aperam is a producer of stainless steel, and we have major plants in Genk and in Charleroi. And to say that we also have a history of collaborating with companies like CERN, for example, to be able to, at early stages of such projects, to better support and describe the properties of stainless steels, which are used in let's say, a quite wide range of grades that we have, offering different properties. Here we would be talking about maybe, I would say, mostly mechanical properties, but also stainless steel working at cryogenic temperatures. For this, we do have a significant expertise. And also, I have not seen it very clearly, but I was expecting also to have requests or for let's say decision making in terms of magnetic properties. So those three fields, having the right mechanical properties for the tube or the different part of the machineries, the right properties at cryogenic temperatures when need be, and magnetic properties. We would like to be part of the project and to help supporting the selection of the grades, making sure that, well, first of all, I can say they are, stainless steel is highly recycled. So in terms of sustainability, it would be something we could describe. But mostly, it's quite important to have the right selection, so that in the end we both solve the problems while having products that are easily achievable. So for cost purposes, I have seen that you are also having questions regarding which kind of how would you put that, covering or protection you put on steel, and there we have we certainly have need to have a discussion regarding which cost that would entail to select also an efficient solution in terms of cost. So only though that's it.
Thanks a lot, Jean-Pierre. So as you have the floor, do you have any comment with respect to what has been said so far about the organization of the collaboration with industry?
I think it's going the right direction. What I hear is that there is this understanding that we should divide in subgroups, identifying the questions that we have to solve, and then evolving around the table the best experts. And this is how we would like to work, yes. That is dedicating our experts to when their expertise is needed. So for me, if we do have the catalog of the technologies and the requests, and we would be able to say, okay, we as Aperam can support this or this group, and that's how we would like to participate.
And that's great. That's
perfect.
But
this catalog has to be built together with industry,
yes.
to be
yes.
developed.
In fact, even the catalog is something very difficult to do, because we are starting from, if you want, the technical specification of the Einstein Telescope. We know which kind of technology we need. Then we have the state of the art of the technology. And then we have this challenge. But the challenge, I think, if we do it alone, without a company, we may estimate it wrong. I mean, a discussion involving the company could be so. You have this expertise that we are missing, and even the catalog. It's we talked a lot with the partner to do it. I asked it for a long time, but it's extremely difficult to do. And I think a collaboration also to build this catalog and involve company in the building of the catalog would be the best way to have it. We are not able yet to provide a finished catalog of technology. Yeah.
No, but it's clear that it is a back and forth and step-by-step process, and that we will identify what needs to be, and then identify the challenges and how we solve them. And for APERAM, the idea would be to say, okay, there we can support, because challenges we have the expertise to support. That is usually what we, I mean, for example, what we have done with CERN was exactly that, to say, okay, we want to build this type of tube, we want to build this type of, let's say, machinery, and there we need to have these properties for the material, and there we can support into saying, okay, and this is hence how you will achieve that.
Yes, exactly. And this is also why we submitted ET to SMEs, because after this very professional mapping of all of you, because you will be really mapped and visible on the map, and we will do very specific company questionnaire. What is your challenge? What is your technology? What is your expertise? What can you bring? How could you innovate? And this will really help. This is going in the same way that what we want to do, to work on the catalog, to know exactly what you can bring. So this is planned, you know, in our mind, we are planning the very close contact with all of you from the start of March. As soon as we have the project, we have a collaboration with business development agencies that will help us to do that. So not only the scientists, but also the industrial and financial partners of each regions. And all together with these partners and the industries and the scientists, I hope that we will create this ecosystem that is really necessary to have this Einstein Telescope here in the EMR. I think we need all of us to get it. It will be a common goal. So as soon as we have information about this project, we will inform all of you. Because for us, it's also a way to be able also to give vouchers and to help companies with money, you know. This is, as you say, we didn't plan maybe enough money for in the present project for the involvement of companies. Okay, so for the vacuum, Christophe.
Yes, for the vacuum. Is there any other partner who want to introduce himself?
And does the ETPathfinder partners have explained the need for the vacuum? Because I know
The vacuum in ETPathfinder,
yes.
you mean? Yeah, but I think maybe Stefan or
because
can comment on that.
as there is specifically a call for tender right now about it, maybe Stefan, do you want to say something about it?
I can say a few words. So for the vacuum system of ETPathfinder, you find all of the details in the tender. Okay, so the requirements, I mean, we touched on them. For ETPathfinder, we are not as strict. We want to have 10 to minus 9 millibar, but still, I mean, it's a nearly 150 cubic meter system, so it's quite a challenge to get to this. So there are certain requirements on the surface quality, obviously on outgassing. There are certain things because we are very sensitive to hydrocarbons. And there's a few tricks here and there, because you need to also get the water content down. As I said, the coldest thing in your system often is a mirror, so you need to avoid that, you know, on your very pristine mirror you get any ice and so on. So all of these details are in there, and they are more or less defined, and with that, more or less vacuum is kind of close to a done deal for ETPathfinder. The interesting part, I think, to really mention for ET is right now to start thinking about these costs. I mean, you see the number that Christoph put up here. I mean, it's 500 million euros for a vacuum system, and that is kind of a lot of money for you know, a low key part of the Einstein Telescope. So there, it would be really interesting, and we have some time to write proposals together and so on, to understand if you can knock off by doing some innovative vacuum technology in the tubing, different materials, different coatings, whatnot, to, you know, reduce the price of this 120 kilometers vacuum system while giving the same performance in outgassing. That would be a really nice project, I think, that, you know, everybody can profit from. So if you have any ideas there, then please get in contact with Christoph or myself or other people, and, you know, because that's really something where there's a huge development needed and a big chance for creating a win-win situation.
Thanks a lot, Stefan. So
Thanks, Stefan. So yeah.
Somebody is willing to say something? No?
No. If
No?
anything else regarding vacuum?
No?
No. So
Just
yeah.
in general, Christoph and
Yeah.
Annick, there is lots of more competences available, several lists, etc. So, but I will take contact with you, because it would take too long to go through all of them, and in particular, they're not all participating at this session. But I will come back to you with much more useful information.
That's great. Thanks a lot. Thanks a lot, Christian.
Yes, thank you very much. As I mentioned also in the introduction here, so I have just shown some example of expression of interest, but the list is longer than that. So I used an old version of the list of registrants. So, but the idea was also to have some words about different industrial involved in the different technologies. So that's, I mean, not too bad, I think, if the list is not complete. So let's switch to the next technology, piece of technology that we need. So we have discussed these huge vacuum towers that we need for Einstein Telescope. And so what is inside this tower is a seismic system. So basically what we want is to have mirrors which are like completely disconnected from seismic vibration down to very low frequency. And for that, we have to use like many, say, oscillator, many spring mass systems stacked in order to really decouple these mirrors from any source of environmental disturbances. And so just to give an idea of what we are talking about, so we are talking about something like 200 vibration isolation system, which means that we need a lot of mechanical, super precise mechanical components like these blade springs, for example. We need many sensors for being capable to measure these vibrations before subtracting them. We need also differential, displacement sensor, many actuators. So, and of course, we need also control strategies and many things in which are all fitting in this precision mechatronics field. So again, I have listed a number of companies here. I don't know what is your reaction about that. If you want to say something, present yourself.
maybe Amos?
Yeah, okay, I didn't represent because, okay, we talked already, but yes, precisely, Amos is also specialized in high precision mechanics and optics. Okay, optics will be another domain, but in terms of mechanics and manufacturing and integration of complex mechanical system, metallic structures, etc. So there we can indeed play also possibly a role in the manufacture and integration of those actuators. Or isolators, sorry.
Yeah, we've heard already about research instrument as well. Maybe about Altifor and Zenith. Are they connected?
Yeah, Altifort is present.
Oh yeah.
So quickly, we are making high precision supra-abrasive devices, which enables, in fact, the glass or the mechanical industry to go, as per today, up to 1 micron. Of course, it's very difficult to understand at this stage of your project if you need to go beyond 1 micron precision of the finishing of the optics or of the mechanical parts. And I think that could be a field of expertise. If we need to go below that, I think that could be interesting for us as well to develop perhaps something which needs to go beyond 1 micron of finishing in either optics or either in the mechanical part or hard materials in general.
Thank you. And do you have any comments on what has been said so far regarding how to cooperate with the industry?
Well, the main question, as I said, I don't know, and of course it's very difficult at this stage to understand how far you need to push your technical boundaries and compared to where we stand today, what is the gap or not, and if we can contribute or not. For the optical components, for the mechanical components, to see if the people who are working on that components, if they need extremely high precision or is just regular high precision. That is something which is unclear, but it's normal, I think, at this stage of your project.
So working on a detailed catalog of technologies is the way to go forward, according to you.
Well, I see Stefan who gave already a partial reply to it. So thank you, Stefan.
Yeah, that was just for the optics. So I mean, for the optics, it's very hard to say. We really need to have, the best of the best for the main mirrors. Obviously, we always display these interferometers as kind of just 4 mirrors and a beam splitter. In reality, there's a few thousand optical elements in there. But if you're really talking about the main mirrors, then there are maybe 1 or 2 places in the world which currently get, occasionally to the requirement that we need. And that is, as I said, for these kind of 50 centimeter mirrors, you want obviously have a super polish on there. But then the key thing, so that's where the 100 picometers come from. But then for the flatness over the central, let's say 30, 40 centimeters, we are talking about RMS values of far below 1 nanometer.
But again, as I said, we could only contribute, I would say, in the finishing of those products, not in the manufacturing of those products.
And that is now extreme for the glass. Obviously, on the mechanic side, the tolerances should be much more, I think.
Okay, thank you.
We are going to talk about optics a little bit later. There is also one item about that. Zenith, maybe. Not in the call.
No.
Maybe. Anybody else about precision mechanics, mechatronics?
Yeah, Jurgen Adriaansen, Absalem engineers in Turnhout. I dare to speak here. We have our background from Philips lighting, so we are well acquainted with vacuum technology, even cryogenics, also processing of the weirdest materials. And then I'm talking laser welding, shaping, whatever. But this all from an industrial point of view. So we have roughly 70 engineers that do machine construction, machine building, but we also have an application lab where we have 20 plus laser systems to produce stuff, to test stuff, and yeah, to look into the borders of what physics can do. And I'm triggered a bit by the number of pieces you need there on the left side. So we are not only machine builders to make millions and millions of lamps, but looking at, for instance, stage lighting or for stadium lighting. There we only make a few hundreds of dedicated light sources where there is quartz, there is tungsten, there is plasma, there is high temperature, all of these things, but then with a very high reliability. So I think we can do some of the engineering, some of the so to say trial and error or the design of specific and also production of this number of products with high precision. So if in our world microns are the standard, that's a bit what we could bring to the table here.
All right, thank you very much. Any comment about what has been about what has been said so far about the how to work together with industry?
Yeah, I think indeed. I work together with research institutes quite often, but then it's bringing the knowledge of research institutes into the industry. So and we are always pushing the boundaries and within manufacturing, and of course we are no longer Philips company, but we made a spin out. But we still bring what is being developed in the lab into industrial applications, and always there the business case is leading. So and is there money to be made, and if there's no money to be made from an industrial point of view, it will not happen. On the other hand, I think indeed that very often I come to research institutes and I see them struggling with issues that the industry already solved a long time ago. And I remember one moment I was at the FOM, so the Research Institute we basic research on plasma, and they had similar problems which we have in high intensity discharge lamps, and I was really astonished that do you not know, do you not understand this? So I think this can work both ways. There is lots and lots of knowledge to be found within the industry, which is already there, they are well acquainted with or already apply. And on the other hand, me personally, I'm always looking for generic problems. For instance, the problem with what was mentioned in the vacuum issue, there is money to be made if we can produce it cheaper. So let's then, and this is a generic problem, and we will have it more and more. Is there not a tool to be found? Is there not a way, an innovative way where we can cut costs if we were to make a tool or a machine or a process that does it just more rapidly? And that's, I think that's the play field where even the industry has hours free. You can always call me if you have that kind of a challenge to think about it, to see what can we do in that sense, what is without any free of charge. So I think indeed, if you have a technical challenge, just bring it to the table with a very good framework. So I really need this. How can I solve this? And you can ask me this on a regular basis. Just how should I say? Kind of like a blog thing that the people are triggered to look into this into these questions. That's a bit my request towards this big science projects. It's all just physics.
And so, do you think that we should, for the next advisory board, that we should, I don't know, I don't know in which format it should be, but and I don't know if this is this catalog of technologies, but maybe we should have somewhere a kind of list of challenge question we have, so that the people from the industry can check. Okay, you are searching for this. Yeah, this I know already the answer to that question. I have that know-how, and so yeah, maybe that is something that we should try to have. And that can be maybe on the website of the project, for example. So list of technical key points. Yeah, that's
really interesting to read this on the one hand, and on the other hand, if I do not have the solution, I have a very good network in people that could have the solution. So it could be really, and yeah, we are engineers. We're always looking to find a solution, and that's please use this broad base you have now. And if we can bring anything to the table, we will do it. And otherwise, we will refer to other suppliers or.
Christophe, I think it can be very useful to expand simply the structure you have already now. So you have here one slide about precision mechatronics, etc. But in terms of precision requirements and stuff like that, it's not very exhaustive. So whenever you have additional requirements in the sense that we are looking for really very high precision and a few kinds of tolerances and this stuff, it allows companies immediately to see, okay, this is my cup of tea, or no, this is just standard material or whatever. So I think the backbone you have already here is a very useful start, and for each of these slides you could simply add each time if you have some major requirements or major challenges, you can add them up, and it will just fine-tune more and more what is exactly expected in this specific field.
This is exactly what was planned to be done, you know. This is really a start of this catalog because we wanted to explain where we are, the state of the art and the challenges, and then see the companies. Yes, this is really what we have in head. And we wanted to show you this. This is the start of the work, but it's really better than nothing. I think we are initiating something. If we can do it with the companies, it would be great. And now we know what we need to add. We will add it, and we will invite companies, maybe technology per technology. So some kind of very specific workshops with very focused companies. Yeah.
Okay. It's Jan van Meer from Kaileste here. I have a general question. Let's say slicing things down and making catalogs is indeed needed and useful. On the other hand, how are you organizing at this moment your design verification process? Because how sure are you that, let's say, everything will fit together afterwards?
Sorry, Christophe, can you answer?
Yeah, I'm sorry. I mean, I don't have any very precise answer to that question. So we are, so there is a concept of Einstein Telescope. It's described in details in the conceptual design report. That's a more than 300-page document that has been updated recently, I think. And so there, I mean, this is not something which is just out of the blue. Okay, so it's built on something, on existing instrument. with validated technology capable, I mean, an instrument capable to make detection. And so what we want is to push this in different directions. So then there are a number of key components that have to be validated for mitigating the risk of the Einstein Telescope. And so this is what ETPathfinder is about, and this is what E-TEST is about. So validating some part of the technology. So I don't know if this is answering your point about how these things will fit together. So for example, for E-TEST, so we would like to disconnect a large mirror at cryogenic temperature from seismic vibration down to one, say, fractions of hertz, or yeah, something like that. And how we can fit things together. So this is what the project is about. So it's really an iterative process. So we have an idea of, okay, what we need there. So, but what is exactly the architecture, and so the compatibility between the different parts. So this is really yeah, an iterative process, and we have calls both for ETPathfinder and for E-TEST. So every week we have a call, and this is what we discuss: progress of the different parts and compatibility, and yeah. Am I answering your point?
Partially, sorry for that. I was muted again. Yeah, I have heard also, let's say, already some references to ESA, for example. If you look to, let's say, satellite missions, what you see is that at regular points in time, ESA or the primes are organizing, say, very formal review meetings where they, let's say, distribute the documents and where they are subject to peer review, and then collect all, let's say, all remarks, check them again on the validity and the relevance of the remarks, and eventually decide for action items before proceeding to the next pass or the next phase of the design. And what you see there is that works pretty well, because it gives people at that moment an occasion to, let's say, really reflect, bring in data, and avoid that, let's say, in the conventional way of business as usual, you avoid to track back and to have a dive more in depth of critical technical problems.
Yeah, that's making a lot of sense. But the thing is that, so Einstein Telescope is not having, I mean, it's not the same as ESA, so it's not working the same way. So for ESA, there are a number of members, and so each member state is giving money to ESA, and the money is like given back to, I mean, a fraction of that money is given back to the different member states through the different manner. And yeah, so here we are not working at all with the same, or at least at this stage, with the same organization. But that would be, yeah, a similar way of working as ESA would be nice, I think.
Mm.
Christophe, I think also that it is relevant to keep in mind which technology packages or which parts of the system are interlinked, functionally interlinked. For example, if you have the mirror part, it is in a closed system under vacuum conditions. It is suspended. The pieces themselves are very precise, and so on. And then on the other hand, you have the the tunnels, the 10 kilometers tunnels, etc. So it is clear, for example, that those packages are different. But when talking about the interface between components which are directly acting as one functional entity, there it is also very important, I think, to collect or to try to collect all the competences around a package. And that package can contain both aspects of precision mechanics and the conditions around it, etc., etc. So there is a two-way approach, in a sense that you can have sterile listings of general competences which are needed. For example, precision mechatronics, that is one specific technology, but it is also important to collect around a combined package, a subsystem or something, all what you need. So that means that there must be somewhere a project manager which coordinates for one specific item. For example, this system with mirror and suspension, etc., combined, so that from these listings of individual technologies, you can really talk about the interfaces of all these technologies within the same package.
Absolutely. Yeah. Thank you very much.
To further comment on Christian, quite often, again, referring to ESA, you do not talk then about a project manager, you talk about a system engineer. So it is a person who, let's say, more on technical level, let's say, looks in integrity of interfaces, of requirements. And he also quite often plays an, let's say, very important role in, let's say, setting up the review process.
Exactly. Exactly. That is indeed the essence of the design review is very often the interfaces, of course, between the different functional systems in one entity.
Fully agree.
Thank you. Any other comment or?
Good morning.
Good morning.
Hello, you can hear me good.
Yes, Benjamin, good morning.
Yes, I'm Benjamin Bulla, thank you. I just wanted to mention that we are a company called Sonix in Aachen, so not far from Liège. And we are dedicated mainly to optics manufacturing and ultra-high precision manufacturing of optical parts. But we also produce precision mechanical parts because in many cases the optics are have to be mounted in some systems, and these systems need to be also high precise. So I just want to mention our company to be one of potential supporters of the optical parts, which is coming later, but also this number 3, the precision mechanics. And to your question on the way how to approach the companies, I think the more precise you can ask your questions about what you need and what you require, the more precise the answers will be from the companies to those questions. I think that's the basis of what I think. Thank you.
Thank you very much, Benjamin. Indeed, we will, with the partner, we will also progress on this catalog of technologies and definition of the challenge. And when we will come back to companies, we will all, so you will really have a clear structure and a clear demand from us. Yes.
I would like to give a short reply. So, and being from the industry part and mass manufacturing stuff with at the edge of the physics, I very often got drawings from people within research, and it could be Philips Research or other Philips, other divisions, where I say, okay, from a production point of view, this is, you cannot manufacture this, but what do you really need? And then very often, if you ask the question, they do not need this roughness or they do not need this accuracy, they need something else. And that's the point where we need to interact. I've gotten pictures where people say, okay, I need to drill a hole of 6 microns plus minus 2 microns. I say, okay, no can do, but I can measure the flow through that hole and perhaps that's enough. And then say, okay, I just wanted to have a certain flow through a hole, but I stated a dimension there because I could not get an offer for anything else. So I think we need to, and that this is cost-driven engineering, meaning you ask what you need and not what you try to get an offer for. And that's the point where we need to interact. I know what I can deliver to you guys. I know what other companies can deliver, to my knowledge, but otherwise we will put in too much money to make stuff that is in fact not necessary.
Thank you very much, Jürgen. I think it's making a lot of sense, your comment. Yeah.
Exactly. I think it is very relevant what Jürgen said, and that's where also this design review of the total system comes in. If you have, for example, a fine tuning of an instrument which is mounted on a robotic arm, and you're designing a extremely accurate fine tuning system on an arm which has not the same precision, it makes no sense at all. And that's indeed what Jürgen says. So either you need to go for a very high precision robot arm at that moment, or if the requirement is not so severe, you should not go for the fine tuning, which goes into very high precision. And that is exactly the, let's say, the functional interface of the different components in the system. They should have the same, let's say, the same level of requirement.
Yeah. I have been in machine building for 2 decades now, and it all changed. There was a time that Philips built everything themselves, but now machine building is what can I buy from which partner or colleague, and when does he get stressed and is charging me excessive amounts of money. So when I need to build a machine or a setup, I always ask my supplier, okay, what can you deliver? When do I push you into stress? And if he says, okay, I can live with that, I can offer you something that is plus minus 1 micron stability over that amount of time, then I say, okay, and within my tolerance buildup, I will look for places where I can, yeah, where can we exchange the microns, so to say, so that the entire tolerance buildup is still functional. And that's also the way, and I'm referring a bit back to, we also have done lots of engineering for ASML, and also there they have their envelope of where does the instrument need to fit in, and what is the tolerance you get, and what is the tolerance that the other party gets, and then you go and exchange. You come to the optimal solution to get it at the lowest cost, and this is real. This takes a lot of back and forth in communication, in exchanging ideas and and drawings and so on. So it's I see it really in that sense that there's a lot of money to be saved.
That's clear. That's very much about reducing this pink area in the bar diagram that I have shown a little bit earlier. Yeah, thank you very much for that. So do we move forward? Yeah, any comment or before we continue with the next piece of technology? All right, so another example is number 4 about metrology.
Yes, sorry, this was Appel van der Wiel from Melexis.
Good morning.
Good morning. Yes, I'm from Melexis. We make systems for cars and just on one chip. what I would like to add, when you start off with a certain idea you want to build, and then in the development process you come up to some hurdles in the implementation that you see, yes, I cannot make this precision on submicron level or whatever. There is maybe another way out, and that is rethink the system approach. To put it very simple, instead of trying to find the most rigid bar, you could think of building a feedback system where actively you provide the stiffness you need in that. So I think in this project, with all the hurdles to take, there will be also a lot of trade-off and maybe I can say trial and error to get to the right system approach, whether you use a feedback or a very stiff material, active, passive, and so on. So, and once you change on that level, you have to start all over again with your sourcing, of course.
Yes, thank you. Indeed, so it's really some kind of iterative process that is needed here.
You see that very often that in the beginning there is a system approach and the system is never questioned again, and that can then lead to an incredible loss of time and effort, and then it's all crisis mode later on to change the system. So along the path it makes sense to question the system now and then. But that has a big impact on your partners, on the sourcing and everything.
Yes, yes, you are fully right. Yes, and I'm very glad of all this reflection and ideas we have from all of you. This is really very constructive. Thank you.
So let's move on with the next one. It's about metrology. So it's very much linked to the previous one. Okay, so these titles are a little bit arbitrary here, but this is just to say that there are a large number of sensors that we need for many different things. So we need the sensor for monitoring the system, the different stages in the instrument. We need some sensor for measuring vibration, some for measuring, from detecting default in the even in the tunnel. We need pressure sensor. We need sensor for temperature, sensor for many things. So some of them are working in the normal environment. Some of them have to be compatible with cryogenic environment and high vacuum. So many sensors needed for monitoring all the different parts of this huge instrument. So here again, I have listed a number of companies that are kind of fitting in this metrology section. So maybe we could hear some words about those who did not have the floor so far. So
okay, good. I'm Carlos is listed first. So
good morning.
I'll take the initiative to start. Thank you very much.
And I thank you for that.
So you see also my face in the meantime, because for the interventions I only use the microphone. So we are at KLS. We are, let's say, located in Mechelen. We are a full turnkey design house, essentially, of CMOS image sensors, but I should talk more in general, in fact, about photonic sensors. So from the moment that you have to detect, let's say, somewhere light in a special way, we are interested in order to participate and develop let's say, custom solutions which can really target your requirements and deliver, let's say, high performance devices. it can be of all kinds. So in that sense, we are really driven by the specifications and the requirements of the customer. In this case, you.
Thank you very much. So any additional comment on the cooperation with technology, I mean, together company and this project? How the involvement? How do you see your involvement here?
Okay, good. At this moment, let's say there are for me still a lot of unknowns. So the first thing normally is to have a better idea about what is exactly needed from, let's say, detecting photons, closing the loop somewhere in those instruments. Let's say until now I've seen only, let's say, some nice pictures about very big machinery which have to or be constructed to detect tiny differences. But of course, yeah, let's say we need to dive in much deeper in order to really comment on potential involvement of Kylesta. But I feel it's an exciting and interesting topic, so that's the reason why I'm present in this meeting.
Thanks a lot, Jan. Thank you. Other one who wants to say something, present themselves?
Yeah.
Yes. Okay. Oh, yeah, Marco, go first.
Okay. No, I would like to express interest from Cosine in metrology. We are a company that develops measurement systems. We mostly optical photonics type of measurement systems. We do system development and system integration. And we have a lot of experience with large ESA projects, doing 25 years of technology development and manufacturing for instrumentation for ESA. And we are interested in both the optics, but I'll come back to that, but also in the metrology part, mostly where optical systems can be used. We do laser systems and imaging systems and single photon systems. Of course, from the generic question on the table, it's unclear what exactly has to be solved and what expertise capabilities are required, but we would be very interested to participate in really the challenging projects where new requirements have to be met that have never been done before. That is where we are best. We are about 50 people, of which about half of them are physicists. So we really work on also developing the measurement concept and then building and developing and building it. And that is also why I always advocate to get us involved in an early stage, because that is where we can contribute most.
Yeah, absolutely. Thank you. So Marco, I'm sorry, I did not get where is the company located?
We are in the west of the Netherlands, Leiden area.
Okay. Ah, yeah. Okay. Okay. Thank you.
Close to Aztec.
Okay. All right. Thanks a lot. Jürgen wanted to continue.
Unmute, that helps. Yes, we are actually almost the same company as the one Cosine. We also built our own fiber optic sensors and our fiber optic measurement systems together with a university in Canada, because it's a friend of mine actually, and that's how it is grown.
Jürgen, which company again?
Phoebos.
Sorry? Oh yeah, okay.
So Phoebos and Stranger Data, we are actually one company that actually built for fiber optic sensors, but we also have our own system where we use strain gauges for measuring more than 200 of minus 200 degrees, because with the glass fiber, it's hard to go any further because of the glass that breaks. So we also have sensors that can go to minus 269 degrees, and we are actually specialized in structural health monitoring, so that we actually can monitor the materials, how they move during the cooling down, and to detect anomalies. We have some algorithms for that. That's actually in a short notice. And we also work for space in a few companies that use our systems for monitoring pressure vessels and yeah, structural health monitoring for satellites. That's in a short note.
Thanks a lot, Jürgen. And so the same usual question. So how do you see your involvement in and what is your comment on the way we are organizing this advisory board, and how would you prefer to get involved in this story? So again, it's a detailed catalog of technology that is the key of the collaboration.
I've been part of some boards for the Flemish government, where they actually organized some kind of poker game, where actually they invited all the relevant companies in the industry. And then they said, this is our problem. We think this will be a solution. And is someone offering this solution off the shelf, or is it feasible, but you need some depth things to get to that solution, or is it not possible? So, and then you could give a score, which product fits most to your company. And then at the end, they contacted all the companies to make their tender actually a bit open to that they could solve those problems and have those sensors or solutions in their monitoring projects. So that was a very interesting way, because then they described for each problem or each step they want to the goal, and then what are the challenges they were facing. So that was quite an interesting approach, in my opinion.
Yeah, very pragmatic approach, I think.
Yes.
Yeah, straight to the point. So yeah,
Yes.
okay.
And then you see also what is on the market, so you learn actually also from. And I believe in co-creation, so I think that would be also an approach. Yes, cool.
Jean-Pierre.
Can I maybe launch here a question, since we have all these companies online? There is something specific that I am looking for, and I'm wondering whether anybody can manufacture or make that. So I'm looking for pieces of silicon or germanium that have two perpendicular sides polished. So let's say a side and a bottom side of a cube, for instance, a cube piece. So two sides which are polished, which are perpendicular to each other. And I'm wondering if anybody of you could make such a piece, and yeah, maybe make me an offer, just as an example. And it is precisely for the challenges in optics.
What precision is needed, or roughness?
I would say something that I can use for wafer bonding. So that's about, let's say, order of magnitude 0.5 nanometer per 10 micron square, something like that.
Okay.
We could
what are
something like that, but I think we shouldn't discuss this here. So please feel free to send us information.
Well, since I don't know many of you personally, and I'm just wondering if companies can make that, and if you can, I'll put my email in the box now.
Perfect. Thank you.
Jean-Pierre.
Yes.
There is a slide specifically dedicated to the coating. So it's the technology number 6. Do you want to say some word about that and introduce it, maybe? Because I think it's very much linked to what your comment here.
Yes, it's just that I need to run in a couple of minutes as well. So.
So then. So as far as the coating is concerned, so we need to have super flat mirror with a reduction of by a factor 4 with compared to the existing technology in Virgo and LIGO, and that is also another big challenge here. Huh? So before you run away, you want to say something about that?
Yes, I think that as written on this slide here, state of the art is these amorphous coatings that are, I would say, commercially available to some extent from different places. I think maybe the best at the moment comes from the laboratory in Lyon, LMA, that did the 2 ion beam deposition sputtering for these type of materials. We are proposing an alternative combination on which we are working, and that's instead of amorphous materials, we want to try that with crystalline oxides. This follows a bit work which has been done by a group in the US that tries to do epitaxial coatings, but on gallium arsenide. So that's more or less, I would say, the competition in the field. I think the biggest challenge here is to make materials which have an as big as possible optical contrast. So a big difference between the low index material and the high index material. So the bigger that contrast, the thinner you can make your coating, and therefore the better the quality of the coating can be. So that's the thing that we are exploring at the moment in 2 classes of materials. So we're looking at perovskites, identifying their high index, low index combinations, as well as in the corundum structures, which are sapphire compatible. Also looking there at high index, low index pairs that would have, that we can grow easily with good quality and that would have low optical absorption. That's in a nutshell the part of the space that we are looking at here in this project.
Any comment or reaction from Solera's advanced coating?
Well, I'd like to make one comment. This sounds very much like the description of a project. And I think, yeah, in this industrial advisory board, we should discuss how we work together on developing the optical and the mirror and the coating technology, and not only focus it on specific requirements. So I appreciate very much the concrete questions for things that companies could do, but I'm also interested in a bit broader picture on the optics development and the coating development. We are, for example, is CoSign, we develop the optics for the next generation X-ray telescopes for Athena. So that is silicon, very high quality multi-layer coatings with extremely high surface roughness requirements in very exotic materials. So we have capabilities and facilities there. But yeah, when we stick to this level of, let's say, very specific projects, it's very difficult to find out and discuss possible involvement of the parties from our consortium and ourselves in these projects. So I would very much appreciate a bit broader way of communicating about how are we going to get the right optics with the right coatings for the Einstein program.
Okay, I think that's something that we certainly can take up.
Perhaps my reaction on this, I'm an electromechanical guy, but nevertheless, I have done a lot of, I'm in process development. I have stumbled upon the guys at the University of Ghent that do atomic layer deposition, and I have seen that they can do fantastic things in very high level of control, uniform layer deposition. So there you have the advantage that it's not a sputtering technology, but it's really atomic bonding. So have you thought about this? And if not, I can put you into contact with the guys that are doing ALD to check whether there's a possibility to bring solutions to your challenge here. That's what I would bring into the table here.
So thank you for that comment. We are actually working together with the people in Ghent in the ETPathfinder project. So we are aware of what they are doing. We are also working on joint proposals with them. So that's certainly something that is taken up. I think one of the things that I did not mention is that a key criterion here for these coatings is that the mechanical losses should be minimized. And so one of the reasons why this ion beam sputtering facility seems to be able to produce the best results so far is that they have a beam which is bombarding the substrate that densifies the coatings. And I think for these type of materials, people in the field recognize that this densification is an important element to improve the mechanical losses. And I think that's also the direction that the people in Ghent are trying to explore as well.
I think this is a very good example of the interaction I would like, or I think which is needed to bring you to the right place. Just, yeah, of course, we do business development, so we know what people are working on. Some things are not, I do not do optical deposition whatsoever, but I know who is working on it. And I think for me, it's interesting to learn what's happening in the outer world. And I think these kinds of fast interactions, and it does not need to take hours and hours of in-depth discussion of what is the best, or I think this is the kind of interaction we will be needing.
That's correct. I also see here a question in the chat about why not gallium arsenide, aluminum arsenide coatings. So as said, these are the best crystalline coatings for this application at the moment. The challenge there is that for the Einstein Telescope, diameters of about 600 millimeter are going to be needed for the coatings. And at the moment, it's already a challenge to have anything on 300 millimeter for gallium arsenide. So these are epitaxial coatings, which means that you need a substrate that allows you to grow these things like that. So that's one of the challenges that gallium arsenide has. Also, the optical contrast is nice, but is not very big, which means these are very thick layers, very thick coatings of maybe 10 microns, something like that. So these are some of the challenges for that technology. I hope that's clear.
Thank you, Jean-Pierre. So maybe we can continue with the other one, unless there is something else we want to say regarding the coating. Because so we have, so there are 8 topics that we wanted to cover, that I have proposed to cover. But okay, so we can maybe go a little bit fast because it's already 11:41. We skipped number 5, but it's about optics. It's about these huge fused silica substrate that we need. So much larger than what is used currently for Virgo and LIGO, and of silicon, Joris is saying in the chat. Yeah, thank you. Yeah, and is any comments or reaction from industry about that?
Yeah, not having capabilities to produce these large mirrors, we're still interested to participate because we are already working for 20 years on the silicon optics for space. So we think we know a little bit about optics and coatings in relation to silicon optics. So we are interested to see whether we can contribute.
Thanks a lot, Marco. Comments from Amos, maybe, or somebody else?
Yes, I can comment. So clearly, optics is of course business for space application or scientific application. So this is definitely something we're interested in. Now, indeed, as somebody previously says, the optics for here the Einstein Telescope are huge, and actually with a kind of super polish that virtually very few companies in the world can do. Now, indeed, the timeline for those optics is still quite long term, and technology is evolving fast. So this is indeed, we discussed previously on R&D and how to move R&D forward. This is definitely a domain where we are working, and indeed there were still technology steps to go through to improve indeed the roughness.
Volledig uitgeschreven, geen export.
Sorry? Okay. So so definitely this is something we'll be working on, but there may be we may have to think about indeed how to build that technical capabilities in the region by developing some R&D program or collaborations indeed to improve technology and reach the level of precision that will be needed for that Einstein Telescope mirrors. And indeed, there is a main optics, and there is also all the other optics that goes around those main mirrors, actually.
Thanks, Xavier. Rapidly, the same question. So, what would be great? I mean, what would be best for you for, say, maximizing your involvement or facilitating your involvement in this project? So, can you say something about that?
Okay, involvement is okay. There were several aspects, but they have been partially already covered by other interventions. Actually, to help industry involvement in this project, first, what has to be clear is, I know on optics, but also indeed on mechanics, suspension, etc., there is still R&D performed in institute to reach actually the objective and the technical and meet the technical challenge of the Einstein Telescope. And at some point, what will be important is to clarify what will be handled by institutes and R&D before, and what will be expected to be handled by industry. Because, okay, industry can invest also in R&D and make progress. That's what we are doing. But at some point, it's important also to know what is done on the side, because it's useless to invest 2 times in the same technology. It's best to spread indeed the fund in an adequate fashion between what is done in institute and what is done in industry. And that will be very key also for the success of this collaboration, because otherwise you may have the fact that for some domain industry will expect that institute will work on this and come with a solution. So industry won't be ready. And if you make a call for proposal at some point, industry won't be able to answer. Or on the opposite, you may do R&D in a domain that industry has already done R&D, maybe not exactly with the same kind of solution, and the 2 solutions may not even be compatible. So you may have to say, okay, yes, we have now to implement things, but your design and what industry can propose are not overlapping properly. The overlap is just a skew. So not only you lose money, but you will lose time also at this point. So clarifying indeed the part that is done outside industry and the part that is done or expected by industry is important. And it's clear that, okay, purely design specific things for this Einstein Telescope will be done by institute. It's already the case. You have already concept design. All this has been done by universities and institute. That's clear. But there is indeed, in terms of maturity of manufacturing technologies, etc. This is a bit really in between what is done in institute and what is done in industry, and clarifying indeed who works on what, or expectation of one side to the others will be key for the success of the project in the end. And typically, indeed, in terms of superposition techniques, for example, this is typically an example where R&D is needed, but it has to be clarified on what side it is expected to be done. And then the second question will be how or through which funds.
Thank you very much, Xavier. Any other comments related to optics? If that is not the case, I suggest that we continue with the number 7 about laser, and maybe I could invite Olivier Fizeau from ILT to present that topic if he is connected. Olivier, are you around?
Yes, can you hear me?
Yeah, I think you are much better than me for discussing about lasers. So I give you the floor if this is fine with you.
Okay, thank you very much. Yeah, so what we are developing at ILT is the beam source for the interferometer. So the goal is to achieve powers of, in this project the power is fairly low. It's the requirement is something between 5 and 10 watts, and the more challenging things are the sensor wavelength of around 2 micron, and also achieving the necessary beam quality and the necessary low noise of several aspects, especially the intensity, and of course also the noise of the sensor wavelength and the beam pointing. So what we are really doing is setting up a MOPA configuration so that we can separate the actuators for the frequency and the power. So this is what we are doing at the moment. So in principle, our research interests are, so some of the challenges are based on the components for the laser. So there is always some improvement that's welcome in terms of the fibers that we need for amplification, but also in crystal materials, but also thinking more about companies that I know from our region. It's there's also some need for improving or developing dedicated electronic sets for stabilization of power and frequency, and to develop the schemes for all of this, like mode cleaning and also beam steering. So I think there are some very interesting aspects in this topic that need to be looked at. And we're starting with the development of the beam source itself at IoT.
Thanks, Jean-Pierre. Any reaction from microwave photonics?
So
Annick is saying that I said Jean-Pierre. Of course, it's Olivier. Sorry for that.
That's fine, no problem.
Too many names.
So no reaction. No one wants to maybe Borit or microwave photonics are present. No. Okay, so then I propose to go.
Sorry,
Yes.
Annick, I have one question. There's no mention here of squeezing, of using more advanced type of laser sources here. Is that also part of the E-TEST and ETpathfinder program? Is that not part of this, or because we're actually interested in that part? I think there are some parties that are interested to discuss the possibilities of producing these lasers and getting some involvement there, but also our interest is in the quantum mechanic, the quantum optics aspects of that.
Mm-hmm. Yeah, well, I think
say something on that. Is there an opportunity to work together there?
Yeah, so there is definitely some activity going on in terms of squeezing. I'm not really an expert on this. I don't know if Milos is present. So Milos Nesladek would be somebody who's involved in working on this. So it looks like he's not present at the moment.
You registered, but yeah.
I don't see him in the list of attendees, but I mean, does not matter. So indeed, it would be nice to get in touch with Milos. So
Okay.
he's really definitely the guy. So he's from University of Hasselt, and he is the guy working on this field within the E-TEST project. Yeah.
Okay, I will do. Thanks.
Perhaps our interest on this, so we are mainly laser integrators, so but then also mainly on material processing. Nevertheless, our chief engineer here has been working within ASML for 1.5 years on the BTS system, bringing the 40 kilowatt laser pulses from the laser source towards the thin droplet. So there's a lot of knowledge and experience in how do I align lasers over long distances in a production environment. How can add these tricks to the trade? There we are acquainted with, and how do we do the steering of the mirrors to make sure that it all keeps in place. So that's our play field. So, but I mainly see that we deliver some engineering guys that are acquainted in this field and have a broad experience in designing in this high demanding projects.
Yes, I think that's a very interesting aspect. So, of course, maybe Stefan Hild can give a bit more comments on what's currently being done in these in terms of stabilizing the beam inside the cavity, because as you said, it's a really a long cavity in the, so at least in the final design, with the kilometers of distance. So you really have to keep the beam very perfectly aligned. So that's very challenging. And I think if there is any help we can get, I think that's very good to know that you have this experience.
Yeah.
Yes, thank you, Jürgen. Any other comments or reactions regarding this topic before we move to the last one? Don't think so. So there is a last topic we wanted to discuss briefly today. It's about control algorithm, control strategies. I don't know if maybe Hakim want to say something about that. Hakim, are you connected? And
yes,
maybe
I'm connected. Yeah, I can maybe summarize a few of the challenges. I mean, from the introduction, Christoph, that you gave on what the Einstein Telescope is, it should be obvious that this is a highly complex object with many thousands of sensors that are needed to operate the interferometers stably. Many of them have nonlinear reactions that have to be mapped out and have to be integrated in the overall control process. Maybe if I can give you one example that I personally find quite fascinating, is that there will be hundreds of seismic sensors around the array that will record seismic waves approaching the interferometer, and those seismic waves have to be reconstructed. And in order to determine the impact of those waves on the mirrors, and then corrected for, in the simplest way, we can do that offline, but it's clear that it will be more efficient if we manage to do that reconstruction in real time and manage to compensate the movement of the mirror in the interferometer. This is maybe just an idea of one of the challenges that we are facing in this area. Thanks.
yes, thank you, Hakim. And maybe also on the top of that, so we, as we were saying in the introduction, so this Einstein telescope is going to be tremendously more sensitive than existing instrument, which means that a much larger number of detection are expected from this instrument, which means that the capability to process all this data is, I think, not ready yet. So there are many activities. I mean, a lot of work has to be done for being capable to process all of that. So yeah, but this is just to give you a flavor of the complexity of this part as well. I don't know if maybe some companies, well, those listed here on the slide or some other one, want to make some reaction or to present themselves and say something about that.
So this is our last technology for today. So please don't hesitate.
Somebody from Spacebell, Fluves, Celestia, Antwerp, or somebody else.
Don't worry. Anyway, we have registered everything, and maybe some company who could not attend the complete event will come back to us, and that's we understand everybody is very busy at the end of the year. I think we can close this focused session on the prototype, and in 2 minutes we are going to the you please stay here, you stay connected, it's exactly the same Zoom link, and we will get back the participant of the geology online session, and we will do the closing all together with the conclusion of all this, the most important information we can take from this session, and also the next steps for all of us. So thanks, but really thank you for all of you, for the 50 participants of this session, and for your participation. It's very nice. We've been discussing 2 hours about prototype. This was the other session ongoing. It was led by Frédéric Nguyen and Florian Amann. And these were the involved project partners.
So, hi everyone. It's a great pleasure to host you virtually here for this first advisory board of the E-TEST project. One thing that is clear, actually, it's the advisory board of the E-TEST project, but it's within this larger framework, which is basically the Einstein Telescope project, and in particular within the Euregio Meuse-Rhine, so in our region here. And I'm here. So my name is Frédéric Nguyen, for those of you who do not know me. So I'm here, chair of applied geophysics at the Faculty of Engineering in the University of Liège, and I'm basically leading the subsurface part with Florian Amann, who will talk after me of this E-TEST project. So I'm here talking on behalf of the E-TEST team, which I will present right away. So I will probably ask the E-TEST team to present themselves, so they can unmute and then say a few words about themselves, so that you can see who we are, basically. So I will start with myself. So basically, we're at the University of Liège, and so in addition to me, which I basically specialize in geophysical imaging and hydrogeophysical testing, so basically testing different aquifers at different scales, but using imaging methods. We have together with me Ananda Sark and Hans Balder Avenit, who can present themselves better than I can do, actually.
Yeah, okay. I am Ananda Sarg, a professor of hydrogeology at the University of Liège. So groundwater and groundwater modeling is my specialty. Thank you.
Thank you, Anna. Hans? You have to unmute, I think.
Yeah, I'm muted on my side. I'm Hans Balder Avenit, so I'm professor in geohazard assessment and geology in also at Liège University, and our group takes care of seismic and seismological investigations and orbit geomodeling and engineering aspects of the Einstein Telescope site.
All right, thanks a lot. We also have a partner, Aachen University, RWTH, and there are several people there.
Shall I start, Fred?
Yeah.
Yeah, my name is Florian Amann. I have the chair of engineering geology here at RWTH Aachen, and there's several other chairs involved from RWTH Aachen in the fields of geology, geological modeling, geophysics, and engineering geology. I think Peter Kuckler is here.
Yeah, I just saw him, I think.
Yeah, I'm here. Good morning. My name is Peter Kuckler. I'm a professor of geology here in in Aachen, specialized in seismic interpretation, 3D modeling, and reservoir characterization. And I'm also heading the new Fraunhofer Department of Georesources and the new Fraunhofer Institute for Energy Systems and Geothermal. Thank you.
Thank you, Peter. We have the University of Bonn with Andreas Kemner, who is here, I think.
Yeah, good morning, everyone. My name is Andreas Kemner. I'm chair of geophysics at University of Bonn, and we are specialized in geophysical imaging with main applications to hydrogeological characterization.
Thanks. And then do we have somebody from KNMI? Because I haven't seen them in the chat yet. Either Sahar or Laszlo. If they're not here, then so KNMI is basically responsible for seismic noise monitoring and seismic hazard computation. They probably join later on. And we have, last but not least, Nikef, and I think I saw Frank Linde here.
Yes, so this is Frank Linde. So I'm the odd one out because I'm not an expert in all these things we discuss. I think I'm more the matchmaker and the client. And Shahar, in fact, is at the presently unloading 200 of these sensors 5 meters away from me, okay? So he is here.
Okay, great. All right, thanks. I think we will get the chance so that everybody can introduce. I will just continue a little bit, and I will give the floor to our guest, the advisory board, to basically also present themselves. I would just perhaps say a few words, and in between my presentation and Florian's presentation, that would be a good timing. I would just give the overall project of the objectives of basically the E-TEST project, which is basically an Interreg funded project first. So basically you can view the project at basically having forming deliverables. The ultimate one would be, with respect to ET, would be to have an optimized Einstein Telescope design in the EMR region, basically. And that's where we're going to be also at one point making a tender, so a call to basically ask for industrial partners to help us with this task. This ET design in the EMR region is going to be also using information from underground models of the regions, and we have 3 of those models with different scopes. One is in engineering geology, one is in groundwater, and the third one is going to be in seismic noise. And the later one is quite important because, as you have seen, we try to actually monitor really small deformation to actually detect the gravitational waves. So it's really important to be able to predict what the seismic noise would be underground. To build those models, we'll basically rely on new data that we will acquire. We will also be collaborating with the industry. So we will gather new data. So we have big seismic reflection lines to get basically the structure. We will have deep ERT. So the tender is now open to also try to map potential karst in the area. We will do passive seismics, geomechanical test, hydraulic test, and we will have 5 drillings in the regions to basically complement the already existing information that is being compiled in this cross-border database, which is the 4th deliverable, which will be open afterwards. After the project, we'll basically integrate all the existing results, and the new ones will be gathered during this project. So this is overall what the project E-TEST will do for the ET. And we will basically do that. The site parameter has been defined. You see here in the Netherlands, you see here Belgium, and you see Germany here, and you see that you have Aachen over here. So you have industrial and urban areas in the middle. You have much less human activities and a lot of more Natura 2000 areas. So it's much more quieter area, and this is where we currently basically focus now our efforts. In this region, we have particularly geology, in the sense that we have basically let's say softer rock or less consolidated sediments on top of the Paleozoic bedrock, which is underneath. And this soft rock has the property to basically attenuate ambient noise. So whether it would be from traffic or from wind turbines, for example, to have a more quieter subsurface 300 meter at 300 meter deeps, where we hope to find a hard rock, so Flaminian rock, where to basically place the cavities or the caverns to basically host the big interferometers. Of course, to be able to design in this particular framework, the Einstein Telescope, we need to know a lot about the structural information. So we need to know where the faults are, the presence of cars, and we need, of course, to put numbers on those geological formations, which Florian will talk about in a moment. So the critical point for us in particular is going to be to define the thickness of these younger rocks, which are going to be important in particular to position the access shafts and the corner points. We might have some groundwater issues and drilling stabilities over there. And then we might find limestones. We can pause the karstification hazards that needs to be identified to finally find a suitable rock to hold the caverns. And we need also to understand basically how those rocks are structurally in place over there. So I kept the presentation short, and I will now ask basically the audience, if you may, our guest, the Industrial Advisory Board, perhaps to say a few words, each of you, about yourself and your interest in the project. And of course, we hope to then continue the discussion after Florian's presentation, which will give much more detail on the infrastructure itself. And the idea here is really that, so Annick said that, so one of the goals is to set up this catalog project of technologies to basically push forward also the position of the EMR region as a potential host for the Einstein Telescope, but also that will go through basically showcasing what the industry can actually put forward as technological development. So that's going to be very important also in the site decision. So it's really key that we have your support in this regard. So I don't know who would start. Maybe I can name somebody I know, so that's maybe easier. So we don't have. I don't know if, for example, Steve Grusla, which is a former student I had in my first year of teaching here at the university, can start perhaps.
Yes, I can try. Everybody hears me?
Yes.
Okay. I find the mic. So I'm Steve Grusla. I'm working in a design office called GeoConseil as head of the Department Geotechnics and Engineering Geology. And I'm also an administrator in a drilling company called Gevatech, which is a daughter of GeoConseil.
Thanks a lot, Steve. I don't know who else wants to take the floor.
I can introduce myself. My name is Joseph Ikmans. I'm working for Tractable Engineering, as part of the group. First of all, thanks a lot for inviting us and this technical board, because we are very keen on helping you out on this matter with our expertise. We have a lot of expertise in tunneling, in underground structures, etc. As you probably all know, the big projects in Antwerp at the moment, we are involved in that, in Paris, in the metro lines, in underground storage facilities for waste. So we do have a lot of input that we can give, we think. So we got the impression that the most important part now is from a geological and geotechnical point of view. So I've brought with me two experts in this field, Serge Godard and Antoine Gaufriot, and I will let them introduce themselves.
Thanks a lot.
Good morning. Everybody heard me? Okay, I'm Serge Godard. I'm a former student from University of Liège. And I'm working for Tractable since 40 years, and I'm specialized in underground structure and tunnel.
Good morning, everyone. Antoine Gaufriot, working for Tractable for 10 years and specialized in seismic hazards and siting for complex industrial sites. Also working in Belgium region, east of Belgium, for surface structure hazards and siting of infrastructures. So we believe, as Joseph said, that we could assist into this project.
Thanks. Hi, I'm Yannick Fessler from Amberg Engineering. I think I can find myself. We are a Swiss company. We have a lot of experience about tunneling. We hold the tunnel in Switzerland with the Alps and so. Especially it's a deep tunnel. Now we are working a lot with the tunnel for the metro lines here in Paris, for example, or in Brussels. Already, we have some people in Brussels, we have some people in Paris, people in Switzerland. We found the project very, very interesting. I think we'll enjoy to participate to it and to help you to read it and to see more about the star later. And yeah, I think with the practice we had with the Alps and the deep tunneling, we can have a good help with this one.
Okay, thanks a lot. I will pick up now the list and go through it, so that'll be easier. So perhaps Joseph Ikmans?
Yeah, I just introduced myself. Sorry. It's from Detector.
Sorry. Rod Eddies?
Yes, good morning, everybody, and thanks for the invitation to this exciting event. Many of you have heard of Fugro. We think we're the leading geodata company in the world, global footprint, but based in the Netherlands, so semi-local in that regard. I head up land geophysics characterization group. I think what is particularly interesting for me here is that when we look at major projects around the world, whether they be major mining or nuclear or civil infrastructure, in general, major mega projects don't turn out well. They don't turn out well in terms of cost. They don't turn out well in terms of time. And I'm particularly excited to see if we can make a difference on this project and actually, unlike many mega projects, make it successful and bring it in on time and budget. And I think a big part of this is reducing the uncertainty in the subsurface. And Fugro is one of those companies that I think can help provide part of the picture. So we're very excited to be involved in the discussion. Thank you.
All right, thanks a lot, Rod. Ben Telkamp is next. Well, if not, then I guess it's Christian Trèves.
Yes, good morning.
Christian.
I will open my video. Yeah. Voilà. Good morning, everybody. Thank you for your invitation, of course, for this very, very interesting project. I have has a first contact with Frederick a few months ago, and my background is mainly in construction company, treating of the geological and geotechnical aspect of the construction. And I will be very pleased if I can contribute to provide you with some advice regarding the construction constraint, which has to be taken into account as soon as possible, and certainly at the moment of the selection of the site itself. That's okay. If I have the opportunity to contribute, I will be very pleased of that.
All right, thanks a lot. Thanks, Perry Pescuti. And if I can just ask you to be brief so that we can afterwards proceed with Florian's presentation and continue then the discussion based on concrete elements.
My name is Perry Pescuti. I'm working for fire safety consulting with a company specialized in fire safety service, fire prevention, smoke control, and fire safety engineering. Because it's for the building part of the project.
Okay, thanks a lot. Walter Frey.
Yeah, good morning, everybody. Thank you for inviting me to this board meeting. I'm running a small company specialized in seismic reflection seismic data acquisition, and also in data projects.
Ja, da spricht gerade Walter Frey.
I have a...
Ich verstehe den Witz nicht. Was?
Somebody, if you did not cut this microphone, I think.
Yeah.
So if you don't speak and I ask you to cut your... Ça marche? Okay, Mr. Fry, sorry again for that.
Yeah, I'm a managing director and geophysicist of a company doing reflection seismic surveying, mostly for engineering purposes, high resolution surveys, and we also did some jobs in geothermal prospecting down to depths in the order of 4 to 5 kilometers.
Okay, great. Thanks. Next, I have Michael Bonivers from the Bureau Graich.
Hello, everybody. Thank you for invitation. I'm a project manager at Graich office in Belgium. Graich is an engineering things that could help in the design of the caverns and the tunnels.
All right. Thanks. My list is a bit shifted, but we can go with Helmut Wannmacher from Pliny, I think.
Mute. Sorry, I have to unmute first. Hi, Frederick. I'm Helmut Wannmacher from Implenia in Austria. So Implenia is a European construction company. And we are quite following this project now for 2 years already, supporting WTH Aachen and NIKEF in some questions regarding construction and cost analysis.
Thank you. And then we have Cosmo Samogi from iCare.
Hi, everyone. So iCare is a company dedicated to reliability and predictive maintenance. And that's the short version.
All right, perfect. Jasmine Targoui.
Hello, everyone. I'm Jasmine Targoui, and I work for Detector. We are like specialized in tunneling and geotechnical engineering, and we've worked on like several laboratory, like underground laboratory projects that are relevant to the Einstein Telescope.
All right, thanks. Then from Oracle, we have Leon Evers.
Hi, everybody. My name is Leon Evers. I'm the CEO of Oracle Netherlands. It's an affiliate company with Canada, Vancouver, working with the British Columbia Museum, the university. We are specialized in 3D modeling and satellite imaging, so remote sensing, covering subsurface for several hundred meters underground and underwater. Latest projects were in high-speed train for looking underground where there were breaches, and the dam construction, which took off very well. We're quite interested in to look in the subsurface terrains of ET. Yes.
Okay. Thanks. And then we have Michel Van Kam from the Royal Observatory of Belgium.
Hello, I'm the head of the seismology gravimetry department at the Royal Observatory of Belgium. We are not yet involved officially in this project, but we follow it because we have an expertise in seismology and gravimetry, seismic hazards also, which should be taken into account. Thank you.
All right. Thank you, Michel. And Michiel Verkroost.
Hey, good morning, Michiel Verkroost. I'm from ERP. We're a global engineering consulting company, and we are involved in several deep underground laboratories in Americas, and we're involved with CERN as well for vibration studies and other specialist items. But primarily, we are design engineers on these type of major projects.
All right, thanks. Mieke de Kraan.
Yes, good morning. I'm Mieke de Kraan. I'm a geologist working at SEK, which is the Belgian Nuclear Research Center.
Okay.
I'm head of Euregis, a collaboration between SEK and NIRIS. Our research is mainly on the geological disposal of radioactive waste. So a different topic, but we have a team of geologists who are very familiar with the geology of northeastern Belgium, the geology and the hydrogeology, so that might be maybe of interest for this project. But I think more important is at Euregis we run an underground lab. It's not that far from Liège or Aachen, it's only 1 hour driving. So, and our underground lab is located at 225 meters below the surface in a clay layer. So we have knowledge on the science behind construction technology. We have, our lab exists for 40 years now, so we have a monitoring, instrumentation and monitoring program, mainly on the one hand to study the stability of the tunnel, on the other hand also to study hydromechanical properties and evolution of the clay layer. So that's in fact mainly our main expertise, the hydromechanical study of the host rock.
Okay, thanks a lot. And Sébastien Virou.
Yes. Hi, everybody. Sébastien Virou from company Geller, company from the BAM group, engineer in geology. And I've been working here for 17 years. And we are, of course, involved in all kinds of civil works and tunnel and underground works. So we hope it could help here for this project as a local actor.
Thank you. And I must jump back up in my list. And Björn Vink is here from Antea.
Sorry, I had to mute. Hi, yeah, I'm involved for some years in this project, living in the area as well, working for Antea Group, and have been mainly busy in the tunneling projects in this area, and know quite a bit about the geology over here.
Yeah, indeed. And then Belten Telkamp, which I missed before, I think.
Good morning. Can you hear me?
Good morning.
I didn't get through. My name is Ben Telkamp. I work for Fugro as well, just like Rod Eddy's. I live in Maastricht, actually, and I run the Fugro office in the southern part of the Netherlands, in the Limburg region. Well, in general, Fugro is a geodata specialist, and we like to bring in all our capabilities where you can put geo in front of, and we would be able to bring a global knowledge on a regional basis. So this is very interesting to us, and we hope that we can be of service to this nice project.
Okay, thanks a lot. I will. I'm through my list, but maybe I missed someone. So if I missed you, can you perhaps just quickly introduce yourself? Otherwise, I would suggest that Florian starts so we can. Yeah.
Yeah, my name is Martin Brown. I'm coming from ESFRI, a big European engineering consulting company. I'm based in Switzerland, and we have a long experience in building underground structures and tunnels. And what is interesting, maybe in relation to the present project, we are actually preparing the preliminary design for the Swiss depository for underground nuclear waste. Which is a very similar situation, a couple of 100 meters underground, large caverns, tunnels, and so on. And similar geological problems like karst. So we are very interested in contributing as well. Thank you.
All right. Thanks a lot.
So there's one, very quickly, I'm Raul Fuentes. I'm the newly appointed chair of geotechnical engineering at RWTH Aachen. And I've got a background in tunneling and geotechnics, geomechanics, and maybe a bit more exotic in the use of robotics in this kind of environments as well.
All right. Nice to meet you, Raul. Okay. Yes?
Yes, my name is Ingrid Dupuy. I work as a policy officer at the province of Limburg. And of course, Einstein Telescope is a major opportunity for the region. And we support parties where we can to make it possible.
Yeah, thanks a lot, Ingrid. All right, Florian, then I will. Yeah.
Sorry, can I also present myself?
Florence, sorry.
Hi, I just arrived. Sorry,
I didn't see you. Sorry.
Hi, everybody. My name is Laurence Delplace. I'm working at Hamburg Engineering, a Swiss company specialized in tunneling and underground spaces. I'm based in Belgium, project manager for the Brussels Metro, and also for Paris Metro Line 17, and also regional manager for Belgium and France.
Perfect. Yeah, thank you.
Okay, maybe
All right.
just
Laurence Ruet from the Interface Enterprise from the University of Liège. So it's a technology transfer office of the university. So, well, in case of collaboration with the project, we will have to work together probably to set up the legal things. Okay.
Perfect. Okay, Florian, I suggest that you.
Yeah. Can you all see my slides? Okay, thanks. Good morning again. In the next couple of minutes, I will talk more from the European Instrument Science Board perspective, where we have put in the last 6 months. I cannot change my slides here. Next one, yeah, where we put some effort in the last 6 months in progressing with the development of the instrument. And there were 6 divisions defined: one on the active noise mitigation, one on the interferometers, one on optics, one on suspensions, and one on vacuum and cryogenics. And one very important also division here is the infrastructure work group. And you see here the preliminary work packages which we would like to address, or which started already to address. The first package is the underground works and infrastructure. Then we have surface, civil infrastructure, safety issues. Of course, we have an own work package, then service plans and the regulatory framework. As I said, there's an active noise mitigation division also, but the idea in this project is not only to rely on technical solutions for environmental noise damping or mitigation. We rely strongly on natural damping of the geology here. Therefore, we would like to go underground, and as you have seen this already today, this is a sketch of the Einstein Telescope in the region here. For that, of course, we have to do a lot now, and we have started already. You can imagine geological investigations and modeling, geophysical characterization. We have to do a geotechnical analysis. We have to think of caverns. We have to think of tunnels. We have to think of access tunnels. Maybe an option here would be shafts, excavation methods, and long-term groundwater drainage. One of the key elements here, you see it already on the corner points, are large caverns. At the moment, our working hypothesis is that there's really huge cavern structures up to 30 meters high with a span of 20 meters. These sizes are under consideration because physicists make a major progress also in the instrument development. Might be a chance that they become smaller, but at the moment, this is a working hypothesis. We have to build up to 30-meter high caverns, which of course requires a lot of consideration, how to access the crown and how to excavate. We have to put the corner points here in outside of environmental noise buffer zones. So there's instrument there, we need to reduce the noise. We have, because of the construction is a triangular, we have not the entire flexibility you would imagine when you build a cavern of that size here, where you can optimize the orientation depending on the structural geological conditions. Here we are somehow limited in the flexibility because we have to build it in a triangular kind of situation. What we are looking for is, for such large cavern, of course, stable, massive ground, and we would like to stay away from major fault zones, which could affect the stability of such big structures. You may all be also familiar with this. So constructing such big cavern is not a simple task. It could be challenging, and here you see an example. This comes from Sardinia. So our colleagues working on the project in Sardinia made already their mind about geomechanical characterization and geotechnical monitoring, how to excavate, how to support such large excavations. Another point is the tunnel. So we have 3 arms with 10 kilometers, and we have to think of the excavation method. Do we want to drill it and blast it, or do you want to use a tunnel boring machine? Here you see the difference in the diameter already. When we have a TBM drive or a drill and blast drive, the excavation diameter might increase, which increases also the mucking and the material we excavate, which has to be stored somewhere. And another point is we have to be absolutely straight, and we assume that the accuracy requirement for the tunnel alignment, especially also during TBM drive, may be larger than we are used to in conventional tunneling. So we have to be really absolutely straight and hit the other corner with minimum deviation. Then we are looking at the moment on the problematic zones. We have not identified any in the region here, in the EMR region, for the stability. So we, of course, don't want to run in this kind of situations here. And we also investigate because we are below the ground surface, and we have to see what is the permeability of the underground. So we also work on this at the moment. But at the end of the day, what we are expecting is there is a steady state inflow, and we have to know the permeability that we can plan countermeasures like grouting and so on. Then the access is a problem because the topography here in the region is mainly hilly to flat. So we have to go from the surface downwards, something we don't like very much in tunneling because we drill a tunnel against the groundwater. There's different options we are thinking of. We have to have in mind that the upper part of the geology is weak rocks. These are very good for damping, but they are not so good maybe for construction. So this kind of options here might not be really an option, but shafts or inclined ramps may be an option. What we don't want to end up, of course, is having the water into the downward excavation. So we have to do a lot of hydrogeological investigations. We start already now, but of course we have to do more than we have in mind at the moment. This also requires them to plan systematic measures, something like a grouting around the shaft construction. At the depth of the planned Einstein Telescope, which is maybe between 200 and 300 meters, it is very difficult and challenging to build a completely impervious tunnel and tunnel lining because a static region would be very expensive. So what we are expecting that we have a tunnel design with an impervious lining, but with drainage. So we have to expect ongoing steady state water inflow into the tunnels. Something we can deal with, but we have to anticipate that. So again, the hydrogeological investigation are key investigations in the project. We have to think of already now how to reduce the inflow, maybe due to grouting. And we also have to think of that we have to tilt the entire telescope that the water can run in one direction, can be pumped off. And of course, also dewatering facilities. The water has to come out here. There's different options possible here. You see in Sardinia, the topography is much higher than in the region here. So what they can do is they can build inclined tunnels where they can dewater the inflow into the tunnel. But in our region here, we don't have the possibility. So we have to think of dewatering tunnels and pumps and dewatering shafts as indicated here. And of course, pumps generate noise. So the pumps have to be far away from the corner points where we don't like to have any kind of noise. So just to give you a scale, this is about 900 meters, but it's a preliminary idea and design. This is something we have to work on. What we are doing at the moment for the underground works, so we investigate here in our region. This is the EMR region, and what you see here are all the outcrops which are accessible for us. We do a detailed geotechnical characterization, structured geology. We take samples, make first laboratory tests, geotechnical laboratory tests, and here are examples from Sardinia. They have existing underground structures which can be investigated to characterize the geology in terms of underground excavation and potential hazards. This is also ongoing work. At the moment, we are planning in the region here, in the EMR region, we plan 5 boreholes. One will most likely start in January, and in these boreholes, we would like to make a lot of investigations. It's not only exploitation, it's also numerical modeling or geological modeling involved. We have these 5 boreholes currently 250 meter deep planned. We plan an excessive geomechanical testing program, hydraulic packer testing with different intervals to get the hydrogeology, stress measurements, geophysical borehole logging, environmental noise measurements after we have finished the borehole investigation. You see it here. This is a completion of one of the boreholes, and you see here this is a carbon steel pipe which is absolutely watertight, which allows us to have a dry borehole at the end of the day to make systematic noise measurements with increasing depth. What is also in planning here on the right-hand side in Sardinia and on the left-hand side in the EMR region is active seismic investigations. So here we plan north to south and east to west sections for passive seismic investigation with a focus on the first 500 meter. So this is where we look for the resolution. Something we also have to start with, and in Sardinia they started already, we have to think of civil infrastructure, surface civil infrastructure, which kind of buildings we need, how many of these buildings, where we can place them, and how we can integrate them in the landscape. I will talk about this in a minute a little bit more. I think that this is a good opportunity to also start with new technologies, CO2 reduce constructions, yeah. So what we have in mind here in this division is we think of a group which is working on visual optimization design, lower environmental noise design, because also these buildings will emanate noise. We are talking about digital twins, industrial Internet of Things, and geographic information systems and building information modeling combined. I show an example from Sardinia in a second. This is the division which will start, or the work package will start very, very soon. Then safety issues. I have heard there's some safety experts in the system. I'm aware that you are very familiar with safety in tunnels, with ventilation, with fire. Here we have something special, I would say, because we have the cryogenics down there, we have lasers down there, and so on. So all these physics instruments, and this requires some special attention also from a safety point of view and from a safety perspective. Also here a division has been defined, and I hope that the work can start very soon on that. Then another point is this instrument requires electricity, and we have to think about service plants. Do we need new power plants? How can we connect to the existing grid? Is there any interference with pre-existing service networks? We have to think that the EMR region is serviced, but in Sardinia there is nothing, so they have to build everything from scratch. And also here we have the opportunity maybe to go into new concepts, renewable energy concepts. I show here the EOS Extreme Large Telescope in Chile, where they started to install innovative photovoltaics to get the electricity for the instrument. So these are the visions, again, renewable concepts, but will be also start to think of. Then we have the entire regulatory framework division or work package. There's a lot of excavation material. Currently, we have to think of about 3.5 million cubic meter of excavated material, and this has to be replaced somewhere. And we started already to look in the region here in Sardinia and here in the EMR region, where our natural protected area, what is the land use of the region? How can we connect to disposals? Is there any infrastructure, roads or railway available? The same has been done already in Sardinia. And as I said, there will be a groundwater inflow. We don't know exactly how much it is, but this has to be disposed. We have to think of the environmental laws of the different regions. Natural parks, I said already, there's maybe contaminated waste and emissions, especially in the region here, the NOx emissions are a problem. All this has to be considered. Involvement of private partners, and as I said before, we have to also plan buffer zones. Where can we build the corner points and where we expect too noisy conditions? What we have done and started, and I think this is quite advanced. You see here we have a geographic information system. We put a database together. The same has been done in Sardinia. Here's an example. This is the cross-border geological model. This was quite a task to do this. Here's the existing boreholes where we could collect borehole information. These are only boreholes shown here, which are deeper than 20 meters, but they give us already a very good idea about the subsurface situation. Then, as I said, buffer zones and interference between infrastructure on the surface, existing infrastructure on the surface, and the corner points is a very important aspect of this project here. I show here an example of the EMR region. What you see here in blue or in red here, these dots here are windmills, for example, and we need to plan a buffer zone around because they emanate noise in frequency which we most likely don't like. So there's a couple of kilometers around, no way most likely to build one of the corner points. And you see also the roads and streets. This is something we investigated at the moment in great detail. Next week we make another passive seismic measurement campaign in this area here. This is the wind park of Aachen, to see how the noise is decreasing as we go away from the wind park. This is an example of what I show here from Sardinia. In Sardinia, I integrate the geographic information system model with the building information model as a platform for the future planning. We at least haven't started on this. We work still on the GIS models. I would like to hand here over to Fred again. This is already my last slide, and I can answer questions if you have after Fred is finished here.
Yeah. So really here the idea of the advisory board is, of course, to be as interactive as possible. So if you have any question about, I'm sure you have, on what Florian just presented, just do not hesitate to unmute yourself. That's possible, right? To unmute yourself. Yeah. I'm just looking at Julia, who is actually hosting the meeting, and just ask any questions. Basically, I was wondering if any of you actually had probably in Switzerland expertise into this issue of the environmental laws, and for example what we do with the waste and the groundwater waste in a cross-border actually framework, because I think this can actually also be something that we have to look at. So opportunities for collaboration. So there are two things here. The first thing is that you understood from Florian's presentation that there are two sites which are basically in competition for the position of the Einstein Telescope, so the Sardinia one, and then the EMR region. So within this advisory board, of course, there are many expertise are much broader than the area, and actually that can go to Sardinia. Within the E-TEST, there are opportunities for collaborations. I would say mainly the points which are listed here. So there is the future tendering of the project, which is going to be the seismic reflection surveys, the drillings, the testing within the drilling, and the observatory installation, which is basically using a cross borehole to perform hydrogeophysical tests. And then we have the tendering ongoing now with the deep electrical imaging for the equipment. And then we have the ET design, basically the cost update on what we actually already did in the past. So just to summarize again the timeline so that we are all aware of is, okay, so we have a question, so I can stop myself. So there is Leon Evers who is asking, you already have been using remote sensing and satellite imaging, 3D modeling for subsurface research. So no, I have not done that, typically because would not allow actually to probe deep enough actually, only for surface information, but not for in-depth information. Except of course, if you work in really resistive environment, like dunes or glacier, for example. Perhaps you want to, Leon Evers, do you want to voice your questions?
Yeah, my question is about we can penetrate subsurface by using satellite imaging for several hundred meters, and we can look about the change on surface level on the level of about 2 meters. So I was quite interested in how far you already got any use of using remote sensing. So you're saying that it's not been done yet?
No, we haven't done remote sensing, but so for you mean for subsurface imaging, really?
For subsurface, yeah.
Now, for subsurface imaging, we're interested here in the geological structures and then geomechanical properties. So that's why we go for onshore seismic reflection, and then electrical tomography, which is more sensitive to the fluid properties. So combining the two, you get that information on the mechanical and the fluid content. But sorry, you were cut when you were saying that you can use satellite imaging to go deep underneath the surface. That's why I did not understand actually.
Yeah, we have the possibility to make 3D visualizations in 3D modeling on subsurface. Let's say we have done that several years since 2006. The Canadian technology has been evolving, so possibly you could add that to the existing technology using at the moment.
Okay, it would be interesting maybe to send us a few showcase of your what you can do in the technology that is behind it.
Yeah.
Yeah.
I can do that.
So
can I ask a question to Leon?
Yeah, go ahead.
Leon, one of the problems we have to think of in this project is that, as I said, there will be drainage towards the tunnel, which cannot be avoided. And therefore, we also expect there might be some surface subsidence problems, not problems, but surface subsidence, a couple of centimeters. And this is something we would like to monitor. Is your satellite image radar, whatever you are doing, is it also capable to measure surface subsidence?
Yes, yes. Okay. We are trying to get on the dike monitoring system. So it's one part. So we want to look in subsurface, but especially on the surface level also. But any change which we can make 3D modeling about that, which have a change on 2 millimeters, which is quite useful I think in this project.
Thank you.
Yeah. Okay. Yeah, certainly. Thanks. Yeah, so well, just do not hesitate to interrupt me. I will just go again through the slides. So I was just going to again just summarize the timeline now that the ESFRI proposal is actually on the table. The decision of the ESFRI roadmap is going to be in 2022. And the site decision, so between Sardinia and the EMR, is going to be near 2025. Frank, correct me if I'm saying something which is off the grid. And then construction is foreseen 2028 and operation of the telescope by 2035, actually. So we have so one thing to do is of course to support this project, the E-TEST, but there are also many other possibilities, I think, to push the EMR forward until the site decision, because so part of it is going to be, of course, scientific input, and a lot of it is also going to be basically also political input, including the economical impact. So you've seen that we are really done with Professor Didier Van Cailly. I don't know if he's here today, but socioeconomic study of the impact of such a large infrastructure in the region. It was quite positive. So we actually here I listed many different possibilities to push the EMR forward, and I think they are much beyond what I actually put. And this is where actually we would ask for your input and also prepare an Excel file that will circulate around by email, so that you can basically position your technology versus the needs of the Einstein Telescope, and also apply for those vouchers that Annika mentioned about in the E-TEST to SMEs, the ET to SMEs project, basically to develop new technology needed to push the EMR region. So we have another question from Rod. Is the current suite of passive seismic surveys only aimed at noise characterization of the site, or is also aimed at characterizing geomechanical properties? Yeah, okay, so passive seismic, yeah, so basically, so one thing is to monitor or to observe the ground motion at the surface and at depth. And then the second thing would be, yes, to use, maybe Hans can say if we were, or Frank, to basically use arrays to also invert, like for shear wave velocity profiles, so to get part of some mechanical properties. I don't know if you want to voice more your question than that, Rod.
Shall I say something?
That's fine, Frederick. Thank you. But if anybody has any more information, that would be great. Thanks.
Yeah, Hans, yeah, you can say a few words. Yeah, I mean,
well, what is asked here, that with the ambient noise, we define also the elastic properties of the ground, and with the arrays that are more flexible, especially for the size. We have already produced some arrays with more than 1 kilometer diameter. We should reach, data haven't been processed right now, it has been done recently. We should reach an investigation depth of about 500 meters, and then making some shear wave velocity logging for those sites, combining with other types of seismics to analyze the elastic properties of the subsurface. So on one hand, it is we use the ambient noise for the investigations, and as Frederick already said, there are also the parallel measurements to test the amplitude of noise and the attenuation of noise over distance from different kind of sources, typically aeolian stations and so on.
Yeah. So on top of that, basically, because we're trying to monitor such small deformation for the gravitational wave, one of the key things to actually suppress what we call the Newtonian noise, so basically the gravity-driven noise that the particles makes by just their elastic vibrations, is to be able to actually predict or model basically the seismic noise. And so this can be done, let's say, at the surface, which is what is being done, for example, at Virgo. But in our case, to predict the seismic noise at depth, we are very much dependent on geology. So that is quite a difficult task. So it's a big topic for also the interferometer itself, the noise measurements. And yeah, so we have a question from Tractable, Mr. Gaufriot. It says that most of the work concerns basically engineering for underground and construction issue, and then it raised a good question about size tectonic activities, active faults, capable faults assessment done. And is this E-TEST site demonstrated as better for fault surface rupture risk compared to the Italian one? Yeah, so that's a good question. So yeah, KNMI is actually in charge of looking at the seismicity issue and the interaction with basically the E-TEST in the EMR region. So this is something that will be looked at in the project. We haven't touched on it yet, I would say. And with respect to the one compared to the Italian one, I think Hans, correct me if I'm wrong, but the Italian one is in a much quieter zone compared to us from a seismic point of view. Huh? And also this was a question that was raised also by Michel van Kamp, I think, already quite a while ago. So this is something that will be looked at into the, within this, also within this project.
So this is Frank. I can confirm that Sardinia is incredibly stable. At least that's what I get from my Italian colleagues, and indeed more stable than our site. Now, whether it's poorer or better, that's not so relevant. The question is if it's good enough.
No. I think for the operation of the interferometer, it won't cause a problem, because if you have like an earthquake, it would basically you would basically just stop the measurements during the earthquakes, right?
Yeah, that applies almost to all earthquakes above, say, 1 or so, anywhere.
Yeah.
And indeed, what of course we don't want is that in the 50 years that we want to operate Einstein telescopes, that our tunnels get cracks. Okay, that we don't want.
Yep.
If I may just intervene just one second, there are
sure.
There are two issues behind my question. One is earthquakes and seismic hazards related to response spectra of the site and engineering construction structures, which are of course a cost in front of it. And the second one is a surface rupture issue, which can deny and prevent any construction. So I would say at the moment, if I understand well, the site which has been chosen, or which is, let's say, developed for site survey already, is not yet assessed for potential capable fault activity and surface structure. Am I right?
Shall I answer?
Yeah, you can answer.
Well, this is a very important issue, and it is an issue that is part of the work package 3, the seismic hazard assessment. And there are specific investigations focused on fault detection and also trying to identify faults which might be active in the area. This work is starting now, and it is fully covered in the project, but for sure we are certainly interested in collaboration together with our colleagues from Aachen also, and from KNMI. Aachen, Klaus Reicherter is certainly also were interested in this work. That will be studied during the next 2 years.
Then there's a larger question about the such a large construction project by Joseph Ickmans, and there are many different aspects basically, and many of you have either well, you can have a large expertise or really specific ones, and the question is, let me just check. Yeah, so which fields would you prioritize, or would we require our assistance? Yeah, that's a good question actually.
I can maybe add a little bit to that. Okay, I see there are many colleagues of ours also present in this, and there's a lot of knowledge, I think, around the table at this moment. And but there are in this kind of projects, the geological aspect, the geotechnical aspect is of course a very important thing at this moment. I realize that. But my question is more, okay, there are several other things also related to this, and where would you need assistance from our side? Because I saw the slides about energy. I heard some mentioning about cross-border permitting, environmental aspects, etc. These are all fields on which we can help you with, but I don't know if it's a priority at this moment. Is it better to have sort of a timing to say, okay, now we first focus on this because this is the most important thing, and then in the later phase we go to other aspects? Or how do you see that? You're muted, Frederik.
Typical mistake. Sorry. It's true that now, within the project, we are currently focusing efforts on reducing geological uncertainties, because there are many with regard to the structural uncertainty, to basically set up a good design. But I would say that in the latest stage of the project, then there will be the question of anticipating the all permitting aspect, and I would say legal issue aspects, I guess, which we are much less familiar with. So I guess this is one area clearly where we would need help. So but basically this also would have to be also discussed in a larger let's say area, because it's also related to the time frame between the site decision, which is only in 2025, right? And so it's sort of difficult to know when to push I would say which area. Certainly now the case is to make to lower the geological uncertainty, to have a reasonable cost estimates of any optimization of the ET design up to 2025. But yeah, I would say anything that would actually help on the site decision. So I'm pretty sure legal issues, I'm looking at Frank also, it is going to be something that we want to take care already now.
Okay.
May I say something about this,
yeah,
Frederik? Yeah. Well, it helps with these large-scale projects to start already contacting the local authorities in an early stage, what we're doing right now with the boreholes. Also with the help of the province Limburg, and I can imagine that the province Liège should contact communities as well in this early stage. It helps you a lot. This is how we did it in Maastricht in the past, because we encountered also different local authorities. So the earlier you start, the better it goes in the further project. You invest some time, but you gain a lot in the future. And in this case, we also post with 2 countries with different rules. You know what's happening right now with the nitrogen output while drilling in certain Nature 2000 areas can be hampering this project on the Dutch side. So yeah, we really need to to get the politics involved as well. Otherwise, we run into yeah, a kind of delay in the future. That's from my side.
I understand what you're saying, Bjorn, but depending on the national habits, I would say, or the national laws, it's a little bit different regarding which country you're in. So and you're also bound by the split of how do you say in each country well, the legal aspects and the rights of every inhabitant of the country.
It is different, yeah.
Is different. So you cannot anticipate everything on that. But okay, it is possible to put a scenario there and to let you know, okay, this is from our German side, this is from the Netherlands side, this is from Belgium side. The phasing that you need to take into account and what and to define the risks on that, and that can be an interesting exercise, I think. But I don't know if it's a priority at this moment because it mainly has to do with timing. It has to do with timing in your project.
But in this case, we should already behave very well.
Yeah, but it means that this actually would need to be well, my feeling need to be addressed before 2024, right? Before the decision of the sites. So that is between 2022 and 2024. So within, let's say, the last year of this project. And there is a comment, or I would say, a comment from Yannick from Ambach Engineering about the environmental aspect. Maybe Yannick, did you want to add something?
Yeah, it was just some feedback from our experience in the CERN. We in the CERN there was the particle collider. So it's a big circular tunnel they did for researchers, and they had two main sites for the construction, one in France and one in Switzerland. So in Switzerland, it was like 20 or 50 meters far from the, a little bit far from the border. And there were a lot of difference of the price because of the 50 meter that the construction site was in Switzerland. They had the environmental laws about if we need to treat the waste or not. We are a lot different. So we had some waste in the Switzerland that was officially polluted, and the same waste in France was totally fine, and we can just put it where we want it. And I think, you know, the treatment of the polluted soil is a lot more expensive than the treatment of non-polluted one. So I don't know how it is between Belgium, Netherlands, and Germany, but I think you should keep in mind with this amount of waste that you will have, that it can have a huge impact where you are excavating the materials.
Yeah, that's true. Yeah, it's true. It's something we did not yet, I would say, consider for sure. And I think it certainly was an unforeseen hydrocarbon pollution. Or
yeah, it was the mostly. It was foreseen a bit.
Okay.
It was known that there were a risk of the hydrocarbon was there, but yeah, I think they underestimate. Yeah, there was some underestimating of the risk of this.
Okay. Yeah, for sure. Thanks.
No risk.
Yeah. So I think this is also something we can also discuss, and also within the ET, not only the E-TEST, and see how best to address this. I think this is a very good, relevant question also on how we can focus, let's say, the industrial support beyond, I would say, the procurements and things like this, and the timing of it, which is critical.
Mood has his hand raised.
That's me, Florian, that's me. One particular thing, what you just mentioned before, came up to my mind. You mentioned before that you actually are looking later stage now on the electricity you need to operate the facility. But one specific thing is already that the construction needs a large of energy demand. So that needs to be already accounted now within all the environmental studies you do, that construction, because if you have a specific place, we also need a lot of energy during this works. So that needs to be also very clear that you have something, if you look now for Sardinia, where you're in a rural area, that you also need to get the energy there. So this is something which is very, very important also, I think, in this aspect. I think this was not within your slide. It was just a slide comment, because the other things is quite straightforward, what I've seen, yes.
Yeah, that's...
Yeah, I fully agree to the discussion here, and I think it's absolutely clear that we have to advance all the fields at the same time and now, and not wait, because there's so many interfaces, as Helmut said, as Joseph said, at Björn. There's also interfaces between, let's say, the grid, the available grid, and the available power plants. If you need something new, also for the site selection and the positioning of the corner points, right? It's all somehow an interface between. And I think to all of the people who are here now, there's a tiny little difference I realized working on this Einstein Telescope between a normal project is that usually you have an owner who tells you up front what he wants, and then you have to make a design around. But here we have in parallel instrument development, which has an impact on the design, and in parallel we plan for the infrastructure. So this is somehow a little bit more difficult situation as for usual planning. And I think when we don't advance, as suggested by many of you now, all the fields, environmental aspects, electricity, safety issues, and so on, I think we are running out of time at the end of the day. So I would strongly suggest to push in all directions.
Yeah.
Yeah, that was just sorry, Florian. It was just a reminder that we also have to, at least if you're saying 2025, there's a potential start of construction, or it was 20 site selection 25, 28, but there was also the range of 27. But if you do think in a rural area, you need at least 1.5 years to establish a functional electricity grid to operate something like this.
Especially in Sardinia, which is not serviced, not as here, right?
Yeah, just the problem is not that you need a constant load, because also we have these peak loads for all of the construction. If you do all this operation, it's quite interesting, and especially what you don't need to forget is if you have to run for 10 kilometers the tunnel boring machine, you have to bring in the electricity also for the 10 kilometers. It means you need a lot of more energy as what you establish for the TBM.
Yeah.
Hi, I'm Antonia Conaro from Amberg Engineering. Sorry, I was a bit late because I was in the other channel, in the other session. I think these are really important points to be tackled on right now already. And wherever possible, of course, we should look into really applying the use of renewable energy. I think that's a must for a structure like that, that will be housed there for many decades to come. And when we look at a European scale, we really have a real mission here to apply sustainable methods of construction and development. And as this counts as well for the spoil, where we can really reutilize the spoil in many constructive ways, which we have, for instance, managed to do here at the Gotthard Base Tunnel, where approximately 90% of the spoil was actively reused in landscaping and in building materials.
I fully agree.
Yeah, fully agree. Sorry, I forgot to introduce you early on. Yeah.
My audio wasn't working at first. I tried. But
okay. Yeah.
Sorry about that.
Okay. So there is a comment or a question from Rod, I think, on the seismic.
Yeah, let me just, maybe I can, it's a rather long comment. So
yeah,
obviously seismic reflection is going to play a part in in populating the model space, because it's that site descriptive model, I guess. It'll be the basis for some of the economic decisions and will drive some of the engineering. But I was just wondering, obviously it's just seismic reflection at the moment. Is 3D seismic envisaged for this site? You know, in the past, it has been quite difficult economically to migrate 3D technologies, say, to the top 1 kilometer, because it's not just a case of using less, it's using the same in a smaller space for reasons we don't need to go into. So are 3D seismic surveys envisaged eventually? Are they on the...
Well, I will let Peter, because he's handling all the seismic, answer that. Peter Kukla.
Okay, yeah, sorry, John. Thanks.
Hi, Peter.
Yeah, hi, Rod. Yeah, thanks for the question. Well, not in the E-test phase, we're running 2D surveys. I mean, there's no doubt that 3D is the better option, as you write there in your chat. I could imagine that also together with the comment we had by Antonia Conaro on the issue of the sustainable. We're running now the seismic survey, the 2D even, to a depth where we could think of evaluating the potential for further use, e.g. geothermal. Yeah, so we just don't want to leave it at a couple of 100 meters. And I can very well imagine that we run in the larger project a 3D survey as well. Yeah.
Okay. Yeah, it was really just to highlight that things are moving quite quickly in terms of acquisition technologies, and you know, whereas in the past you would have to, if you like, sequentialize data, there are now means to more sort of parallel activities that mean that, you know, multiple seismic sources can be employed in the field, which means that production rates can be 2 to 3 to 4 times or more faster than they were in the past. So those technologies exist in the oil and gas sector now, and it's just to make the point that if you were to think about 3D, which has a number of advantages over 2D, which we won't go into, you know, and there are the technology that can be migrated now to these depths. So just a thought.
Yeah. Okay. No, thanks. I'm fully aware of that, and I myself have a 10 years shell behind me, and we're working with all the majors still. So yeah, no doubt about that. Yeah, thanks, man.
Okay. Thanks. So Alain had the questions. So Alain, do you want to?
Yes. Thank you, Fred. I take the opportunity to ask to people who have some, let's say, practical experience with underground excavations and tunneling, if there are other options that to let the water be drained by the tunnels and underground excavations after construction, because of course any drainage and pumping, even if we organize the pumping far away from the Einstein Telescope, would create some noise, acoustic or seismic noise. I'm not a specialist about that, but it's creating some noise which can be a problem. So usually we know that when we are organizing a drainage, we are also mobilizing what we call the head losses and in the fractured media, and which is good for the security of any underground excavation because it's decreasing the pressure on it. But here, the ideal solution for the measurements would be impervious walls, but is it realistic or is it completely not realistic? Do you have some? That's my question. I don't know if there are some people around that can help us on that question as well. Thank you.
May I answer your question? So I'm working actually for a tunnel construction company, and we're dealing very, very often with this problem of leakage and towards the tunnels. Wait a second, I can also just It's very unpolite of myself. We are working with this topic very, very often at various construction sites. To be honest, if you have not an inherent impervious rock mass, yeah, and you have certain fractures within and you're below the groundwater table, there's always some water, dripping water to be expected. And to be, if you have the premises so that you are below the groundwater table and you have a fractured rock mass, you are technically able to decrease this amount of water inflow in the range of liters per minute. So that means very, very strict ones go below 8 liters, 4 liters, 5 liters per minute over certain sections. That is technically possible. And you have then to look on different solutions from the tunneling perspective to deal with such a water. And this was already discussed. So these are already some solutions on the table how to deal with such problematic conditions. Because the restraints, I think, for Einstein's telescope are very, very strict. What I have learned towards the noise which can be generated out of this one. I think, but Florian, what I do know is really, really aware of this problem. Florian? He's muted, that's the best one. But technically that's something you really can focus on, yeah? This is something in the range of liters per minute. This is technically possible, yeah. In the range of 100 meters, something in this range, sorry. Florian, do you want to add something?
No, I just agree. There will be, with what we know for the moment, we have to expect there's inflow and we have to reduce it to the minimum possible. I think I said already at least one word about crowding, local crowding, or even systematic crowding in some of the zones. Yeah, Alan, the problem is you can build a tunnel lining which is absolutely tight. It has been done, right? But you cannot imagine how much costs you add. But you want to have it totally tight without drainage, right?
If I may add something to that, our experience is also that, okay, completely watertight, well, in practice, it doesn't exist, to be honest. It's more mitigating problems, and it's looking at ways how to deal with the water intake. And if it's about a liter per minute, it's quite limited, I think, if that's the calculations that you've done until now. But I think it might be interesting to maybe also in this group, but to think about more other solutions to deal with the water. Have you thought, for example, about buffer capacity, creating that, and not, let's say, continuously pumping up water, but maybe once every month, I don't know, to reduce seismic, to reduce vibrations coming from pumps, etc. So I think there's maybe other solutions to it that can be thought of.
Yeah, maybe I comment on this, Joseph. Thanks. We thought about that, the sump, that we build a sump at the station of the pumps that you can pump maybe every 2 or 3 or 4 months, but we have to design for the volume, for the retention basin and whatever. And for this, we need to know what we anticipate in terms of steady state water inflow in the long term. That's why we put a lot of effort at the moment to understand the transmissivities of the ground and how much we can improve it by grouting. And based on this, we will come up with an estimate of the steady state inflow. And that will be the key to design these sumps.
Yeah, I also think that the seismic noise generated from the steady state flow is not so much in terms of Newton and noise from the last discussion we had with Jan Arms. So this would actually also need to be studied. So this, until what level of actually flow or variable flow can we actually have a safe measurement? Yeah, somebody wanted to say something. Sorry.
No, I just wanted to add that okay, it's depending on what you design. I think it's a work in progress. I think dealing with water intake is something that you will need to think about for the operation of the Einstein Telescope. And like it is with most tunnels, things will happen. Maybe there will be a small rupture or a seismic event that will trigger other things that will maybe increase the water intake. And then, but there are ways to deal with that. If you have your civil concept in order, so that you can deal with these kind of situations, that will help you in the operation of your Einstein telescope. I think we need more look at that.
Yeah, fully agree. Thanks. I think there was some question. I don't know, those were answered. Alexander had some question. I think Rod answered directly in the chat on the type of seismic sources. Do we have any questions? Other questions or comments you'd like to make with respect to the?
Yes, perhaps, if I may.
Yes, Christian.
One aspect is very important in terms of construction method, and this should be addressed as soon as possible. Obviously, to design a large cavern 300 meters deep with no leakage, we just speak about that, will be quite difficult, expensive in terms of volume, etc. And I think that there should be some thought dedicated to the reduction of the optimization of the design of the architecture, I will say, of the cavern in terms of construction method. It's not the same price to make a pit of here's a pit 30 meters in diameter than a pit in 10 meters in diameters. And so that should be addressed as soon as possible, because this can have an impact of the investigation of the soil parameters and so on. And this has also an impact on the volume of water, the ingress water expected. But I agree, when you are drilling 30 kilometers of tunnel, it's a dream to think that you will not have any leakage. You will have a certain quantity of water. Perhaps there are some mechanical means to find a way to pump or to evacuate this water with the minimum noise production. But there should be some think tank about this problem.
Yeah. Thank you, Christian. I think there has been some probably Florian will want to speak now, some optimization of the cavity design, right?
Yeah, this is what I said, Christian, before. It depends also on the specifications we get from the instrument side, right? There's a lot of development on the instrument side, and if they optimize the instrument with new technologies, maybe become smaller, and then we can adjust the size. What I showed with the 30 meter is maybe already outdated, right? It was hosting an instrument as it was looking like 6 or 8 months before. But there's so much development going on. I think Frank Linde can say more about the development on this side. But this is exactly what I said before. We have to adapt the design to the needs.
Yes, but the point is that if you find, if you are looking for a supple solution with a large cavern in which you can make whatever you want and adapt of receive any new technology which can be developed in the future, it will be, of course, more comfortable, but a lot more expensive than if you adjust. That there is a trade to be done and to be made. But this, I just want to support the fact that this will have a very large impact of the cost of the project.
Oh, Christian, this is Franklin. I thank you very much for this statement, because this is exactly what I'm conveying in the collaboration, because I am not a hardcore gravitational wave scientist, and my colleagues sometimes seem to think that they can raise the ceilings to 30 meters and install attenuators which are max 20 meters high. And then I think that free space of 10 meters above is not so free at all. It's very expensive. I think Helmut knows that we changed the designs compared to the design of 2011 enormously. In 2011, there were circular pillboxes with diameters, I think, of 100 meters or so, huge, which is completely impossible, I think, to make. Then we went to these elongated caverns, and I can assure you I'm still pushing them for being a bit more realistic. Once you have installed this wood of attenuators, 100 to 200 of these vertical towers, I think you're not going to move them all around 10 years later, because that's completely crazy. So yes, you need some flexibility that you don't run into the walls, but you don't need whole soccer fields of flexibility. And we are very much aware that it is a costly affair, okay? So this will get attention the coming years. And I'm very happy that there are so many geologists now in our collaboration, which were not there in 2011, that I'm also quite sure that this will get some more reality in the designs of the caverns, notably.
Yes, but this flexibility can be induced by additional works in the future if new technology are developed and so on. And this opportunity and this means to allow for an evolution of the design of the cavern in time in regards of the new technology should be integrated in the early design. That's not so a point, but I don't think that this cavern of this project will have a lifetime of 30 years, 40 years without any adaptation, evolution of the design. That's not possible. It will have to be adapted, developed, restored, perhaps. Because we spoke about the leakage, the flow of water, the point is that due to the evolution of the stresses around the caverns or around the tunnels, new leakage may appear after a time. And this has then asked for additional grouting of additional work. Some maintenance work has to be integrated in the design. And another aspect is also the thermic maintenance of the tunnel. With so many machines and power in use, ventilation and temperature control is also an important topic.
Frank, I agree. I'd just like to ask something. We did a very preliminary study on the cavern excavation, and I think we already raised this topic within. I think that everybody's aware of this. If we do this excavation, let's put it in another perspective. We already focused on doing pre-excavation grouting within this one to reduce the leakage. Yeah, and I do agree, and I do emphasize that you still need some additional solutions how to seal off additional water leakage towards caverns, because it's very important. Because later on, and Florian knows about this in particular, because he has faced this. What I do remember, that it's very, very complicated to get specifically on top again and do some post grouting, something like this. So this is something which was already addressed, and I think it is one of the most important things what you can have a look at when you look specifically on the cavern construction. And as Frank said, I think it's very important, yeah, to actually decrease the size of these caverns to make it more cost effective in the end, because every meter you need to get up access to these caverns. I think this is something which should be focused in the next future, because this is very important for the project.
And in fact, let me stress, we are not anticipating that we are going to have dry caverns. Eh? I mean, we certainly are aware that we will have water, okay? And the issue is, of course, how much. I'm convinced we are going to have far, far, far less than what they have in Japan, okay? I forgot the numbers there, but that was really horrendous, the number of cubic meters there per second.
Yeah, it's huge, but I think it was a conception mistake, right? In Japan, when I saw the presentation, they did not anticipate at all the water issue.
Yes, but they are operating.
Yeah.
So in that sense, yes, it was a mistake. We are not going to make that mistake. And I think we are going to be orders of magnitude lower than what they suffer in Japan, where they still run their machine, okay? So far with poor sensitivity, but okay, they only just started.
Yeah.
Maybe one word to Christian also. There's different things we have discussed also, house-in-house solutions for the cavern, right? That you have your excavation and you make a house-in-house kind of solution. But I wanted to say something else that everybody's aware. At the current stage, I would say we are in a feasibility to a basic design stage. And the detailed design will come later when we know more about the ground. But at the moment, we are really in an early stage, I would say, of a construction design, feasibility to basic design. So things will change and adapt and optimize in the next years.
Obviously, I agree, but I think that the cost of the project will be also an important element in the comparison. And if we can reduce the cost by a few 10%, it will be always useful.
Yeah.
But of course, we are at the very early preliminary design. That's of course, but okay. Just keep in mind the fact that the construction method and the cost of an excavation of a cubic meters of a rock, 200 meters or 300 meters deep, depend on other elements that only the huge volume. The dimension of the excavation is also an important point, but that you know, of course. But
yeah.
I think that there are some consideration to be addressed to this evolution and to the optimization, preliminary optimization, I would say.
Yeah, I fully agree. Also for the cost estimation, we have to think of the current situation and not of future developments. And the design I showed before would be able to host what we know now from the instrument. Maybe in 3 years it's much more optimized, and then we can change it. But the costs will reduce and maybe not increase when we go for the optimization. One question I have about the construction method. We have to hit from one corner point to the other corner point. We have to hit exactly by a couple of centimeters over 10 kilometers the other corner point. And this is quite challenging, I guess. And I somehow have the feeling that the technology to run a TBM with just accuracy does not exist at the moment, or maybe it's somewhere in a cupboard.
No, wait, now I'm confused, Florian. I think this we extensively discussed also with Helmut, and the accuracy, I think, was 50 centimeters. And the implications are that the inner diameter of the tunnel has to be made a bit larger than what we strictly would need if we were able to make a perfectly straight connection. So I repeat, and Helmut should contradict me, that my recollection is that the precision typically was 50 centimeters, and thereby we made the tunnel 6.5 meters instead of the 6, I think, or 7 meters instead of the 6.5, which we needed. I forgot now which one we needed, 6.5 or 6.
Yeah, but I think that the specification from a laser beam is the very small diameters. So actually what we have to secure is a free flow of the laser beam on and return all under 10 kilometers. And I agree that that's something that has to be addressed in tolerances in the design of the diameters of the tunnel to allow to find an axis and to secure the free flow of the laser beam.
I think also, I mean, I haven't been involved in the prior calculations, and I don't know what you have come up with exactly, but what we should really consider here also is, can we couple this cavern development or these underground structures with other uses? Can, for instance, energy provision, energy storage play a role here? Because we have really seen in various examples, and I speak here from the role of the ITA Committee of Underground Space, which I co-chair, that in such structures, when we combine uses, be it telecom with transport, be it floodwater drainage with road tunnels, whatever it is, we have a system now proposed in Switzerland, the cargo souterrain, which will be cargo transportation underground. They're not going to just transport cargo. They have coupled up with telecom, with the Swiss Post. They will deliver parcels. They will have storage areas there, maintenance areas, depots, and so on. So what I'm saying is, I know this is a scientific project and it's fragile and it's sensitive, but we should really consider, can this also be used for any other purposes? Because that will enormously bring down the cost and immensely increase the efficiency.
I can comment a bit. I don't think it will bring down the cost, but it will, of course, increase the efficiency if you use something for multiple purposes, but you certainly don't get a cheaper tunnel by using it for someone else. I think Michel de Camps from Brussels can comment on the uses for geologists, and of course all the geologists can do as well. And I think also maybe for biology, bacteria underground, we could find some use. What we certainly are not going to do is, of course, underwater storage, because we suffer enormously from water moving, and we don't want to make an underwater battery in one of the caverns of Einstein Telescope. That would completely put away the sensitivity we need. And I think that applies to any use which requires a lot of human presence and interventions and simply masses moving from one place to another. Because we go underground to avoid wind, moving air branches and leaves and rain. So just any mass which moves around, that we are not going to open it up to lots of additional moves underground. But of course, we are open for anything which does not jeopardize the sensitivity of this incredible instrument. I repeat what I said in the past, and it's not my invention, but if you put half a droplet in the Dutch IJsselmeer, the increase in the level of the IJsselmeer, that's what we measure, okay? And I think by the time it really works, it's probably 5 times better than that. So it's a fifth or a tenth of a droplet in the IJsselmeer. So that's an astonishing precision, and you can't imagine how you can disturb that, how easily you can disturb that precision.
Yeah, I didn't want to imply to say that we would store water there. That would make no sense whatsoever with this kind of purpose. I thought more something like something static, something that is absolutely, stable. But bringing the cost down, if you have other users, there is the definite evidence that you can bring the cost down if more people can, if more facility owners or operators can benefit from the structure as such.
I must admit, I don't understand that. I think the cost of the infrastructure is going to be, we think, 1.9 billion euros, and it could be more expensive later on. That's up to the bidders to say. But the cost is what it is. Of course, if you have more users, then the cost per user group goes down maybe, but the cost itself doesn't suddenly become cheaper if you add another user. That bridge behind you, that Golden Gate, that costs what it costs. And whether you allow trucks to drive on it or trains or cars, it certainly doesn't become cheaper, at least as far as I understand.
Yeah, correct. The construction cost will not go down, but the life cycle cost will be more interesting. And we're looking at a structure that will last for over 100 years or whatever.
I would like to make a comment as somebody who is involved in the cargo souterrain, which you just mentioned, Antonia. I mean, the reason why in cargo souterrain the owner is, or the developer is looking for other uses is the cost, obviously, because it's a privately financed structure. But as somebody who is involved in the development, I would also like to stress it makes it more complicated if you get other stakeholders in a project, in particular when you have a project which is not yet properly defined. Somebody else made the remark earlier I think it was Florian actually, who said we don't know yet what is actually at the operational stage in our structures, in our tunnels. It's all in development, and therefore I just want to raise a small flag of warning when you get other users involved in a project which is constantly changing. It makes it more complicated. So that should be also considered.
So the only current co-using idea of the underground facility is that an underground research lab is established, which has nothing to do with the gravitational waves. As Frank already said, maybe open it up for biologists to make studies, to geoscientists, like a Monterey underground research lab, smaller of course, or a Grimsel test site. This is one vision where we work at the moment on with a group of geoscientists. Biologists are not involved so far, but this is something which does not produce large noise as long as we go for non-destructive kind of field experiments. This is something we collect at the moment and would like to make a suggestion, and maybe this also gives us the possibility to raise additional money for the Einstein Telescope.
Sounds like a good plan.
Hello, hi, it's Raoul here. So I was thinking about the ventilation of the tunnels that I think somebody mentioned earlier. I think it was Christian. But it may not be a trivial thing to solve if, depending on the vibrations that are allowed within the tunnel and what mechanical systems, because of course, if you want to span big, you want to not have any ventilation shaft, you will need a bigger mechanical system, but of course that will induce vibrations. And if you want to reduce that, we may need to have more natural ventilation through additional shafts of some sort. And that is clearly something that has to be thought about very quickly, I think as well, because the ventilation will, if we want as much natural ventilation as we can, we're going to have to need perhaps more shafts that we're expecting.
I would fully agree, Raoul. Ventilation is a big question, and it depends also a little bit on how the instrument is operated. Where is it allowed for people to go? Are they hanging around in the tunnels, or the tunnels are untouched? Is there anybody during the measurement? How many people are there? Yeah, this is questions we have somewhere here in mind. But it requires, as I said before, action now. Also to sit together with the physicists, define where and when and how long people are underground.
Yeah, yeah.
Yeah. I'm sorry, I was being cut out because my Wi-Fi is actually not very stable. So we are.
I have a question, perhaps.
Yeah. Go ahead.
Just to have a better understanding on the requirement of this tunnel, is the laser beam expected to be put in a steel pipe, or is it expected to run free into the tunnel? Because in that case, you will have to secure also a very clean air. And it will be quite difficult in a tunnel, in a concrete tunnel anyway.
Yeah, there's an entire group of physicists working on. Frank can much better answer this question, but I think he's busy. The laser will run into vacuum tubes.
Voilà. So as long as the tunnel can house this tube, which has to be very straight and with a very fine accuracy, the tunnel is okay. And for construction method, for construction reasons, the tunnel will always be 4, 5, 6 meters in diameters. It will be large enough to allow, to house the vacuum pump pipe.
Yeah, so indeed I was distracted for a moment, but what you should realize there are 4 vacuum pipes in, and not 1. We have 4 of these pipes, which are about 1 meter diameter, and we have to install them in situ. So that's why we, after lots of debate, converged on an inner diameter of 6.5 meters, and we still think that's pretty cramped to do all the welding of these 4 very large vacuum pipes on top of each other. Now, I apologize indeed, I was slightly distracted by my colleague here who had a question about sensors, okay?
I know there was a question about using like mild steel, so low carbon steel instead of stainless steel.
Yeah, this is
also
also
reduce the footprint.
Pursued at the moment. In fact, we in the Netherlands, of course, discuss with Tata Steel and some companies. Also, our American colleagues do this. And yes, there are advantages of mild steel. There's much less hydrogen in it, which is a good news. And it's, of course, cheaper. On the other hand, there are also disadvantages because mild steel rusts, and that we don't want at all. So it's a huge R&D effort if you really want to make that step. And I personally have not have the real number in front of me. What the calculations I did is that the stainless steel itself is between 25 and 50 million euros for Einstein Telescope. And if that's true, then I would not go into mild steel because the overall vacuum system we think will cost 600 million. And that's all the labor to really get it welded, installed, pumps, etc. And it's not that I want to throw away 25 million euros, but really the risk you put yourself in by diverting from an extremely well established way of making 10 minus 10 millibar vacuum systems, namely stainless steel, and then go to mild steel is, I don't think it's worth 25 million. There is one other issue related to the vacuum pipe. We have to bake it out, meaning heat it up to 80 degrees or higher in order to get the water stuck to the inner surface out. If you don't, then you don't achieve the 10 minus 10 millibar. And baking out 130 kilometers of vacuum pipe underground is almost forbidden, okay? That's going to cost you enormously. So that's an issue we are still worrying about how we should address that. In the United States, is one of the limiting performance sensitivities for the facilities they have there. So we have some challenges there. I dare to say that those challenges we will solve our community. I'm more worried about the challenges making the civil engineering, I must confess, and all the geology with all the cracks I see, etc.
Okay, I think we're close to the closing time. Actually, in 5 minutes, we have to go back to the the main session. First of all, thanks a lot for all the different inputs. I think this was really fruitful and many engaging discussion and quite a lot of enthusiasm from all of you. So thanks again for that. Thanks for answering. I guess one of the key questions that was asked earlier and that is again raised by Joseph here is given your large expertise, is how can we actually how we can get the best out of it, and when and where can we actually focus the efforts. I'm not sure I actually have the answer right now and what the next steps should be, but we should definitely think of ways we should engage because there are many different topics here, which is very good for brainstorming and going through different things. But if you want to have more concrete impacts, it would be good to actually think about concrete actions or next plans ahead. Or like could be very concrete actions like in the ET to SMEs with voucher development, or submitting other proposal, or having participating basically in our work for certain parts. So I think there are many different ways we could actually go. So I would perhaps suggest that we discuss this internally in a smaller group because it's easier, and then we get back. I think it would be more efficient this way. But we would certainly be happy to pursue the discussion with you and other action. I would say in E-TEST and also outside of E-TEST, because I think there are also other opportunities that we can knock some doors on to also get some other project running. So that being said, I will meet you back in the main session. I don't know if anybody wants to add other words.
Yeah, I would like to add something like I have the feeling that it's now ending like we have a lot of common sense knowledge working together. I think it's a very nice cooperation, I think, which is cross-boundary and working. My question is how are we going to proceed from now on? Is it just like falling apart, or is it just, can we go to teams which can co-work together on the problems we can assess? Frederick, maybe you have an answer to that.
So sorry, you were cut, but the question is how to go forward from now as a group, right?
Are we to proceed from now? Because I think there's a tension that a lot of people now have more questions than answers at the moment. And in order to cooperate, I think there would be like a scheme or how they can work together. Is there a kind of a sense how you want to operate on that, or?
Yeah, there are different things. There are areas where we can actually, I would say, cooperate directly within the E-TEST proposal, and that work is very well, I would say, defined, and I will send that to everybody. And then there are areas which are actually much more open, and which they would say more rely on I would say core funding that we would put into the work. So in that, I think there are other opportunities that we can apply to. I was for example mentioning the voucher, and I think we could try to actually come up with plans, but within a smaller group. That's what I was saying actually. So we meet tomorrow as a steering committee of this Geo E-TEST part. And so I think there we can. It's easier for us maybe to see how we can proceed in the next step as a group. Certainly counting on you and seeing what is actually would be feasible and in which time frame.
Okay, thanks for the answer.
Yeah.
One last comment, excuse me. I'm putting a link to everyone in the chat. We have a webinar coming up on December 16th on innovating underground spaces. And we're actually showing how in our Hamburg group co-owned, co-shared Hagerbach Test Gallery, which is an underground facility of over 5 kilometers of galleries and tunnels, where we're demonstrating applied uses of innovative uses such as underground data centers and underground green farming and tunnel digitalization. So we really try to combine uses in existing underground structures, and it could maybe be of interest for some of you to watch. It's an hour on December 16th.
All right. Thanks a lot. We'll certainly note that down in our calendar. All right, then. We'll see you in a moment then in the main session. And thanks a lot again for your participation. Thanks, Florian, for the input.
Thank you.
Thanks, everybody. Thank you.
See you. Yeah.
I can say that we had very, very good and interactive session during 2 hours. I hope it's the same for you. Great. What else? And welcome back to all of you. People are still coming. And what we will do now, it's a very short conclusion of both online session. Of course, we won't start going into the detail of everything. But you can see that for the prototype session, Christophe Colette just published in the chat a summary of all the very most important points that he noted and the most relevant remarks and very constructive remarks we got from all of you. And this is what Christophe wrote, and please don't hesitate to say now, maybe orally, if you want to add something or to write it in the chat about this prototype session. So our focus is to have the best collaboration from now on with the company, and not to put you into the accomplished situation, but to work with you on the challenges to be ready for the building and functioning of the Einstein Telescope. Okay, so I see. Okay, so this is for the prototype. So maybe Frédéric, did you do a kind of very small summary, or can you just say in 1 minute? Huh?
Yeah, sure. No, so we had maybe you can, if you don't shut down your microphone, I have the Larsen. Okay. Yeah. So so no, it was 43 participants, very interactive. So first presented the project overall, and then has a very nice discussion on many different aspects that range from basically issues regarding cross-border environmental laws or legal issues, modeling the subsurface, seismic risk assessment, how to deal with the energy demand from the project at the beginning and during the project, tackling the timing issues, considering renewable energies, improving the imaging with 3D seismics, talked a lot also about water mitigations and cavities optimization with regard to the development in parallel of the instruments and how basically that evolve and impact the cost at the same time that we actually have to design the ET and also and estimate the cost, and also discussed about ventilation shafts, also to avoid vibration due to I would say ventilation motor engines. I guess key question we're asked at the end, which is a bit what Christophe summarized also in the chat, is what do we do next? How do we proceed in the next steps? Which is not trivial. I think, of course, first there is this NDA that needs to be signed, which I guess you will talk about a little bit on. And then, of course, beyond, I would say the tender that's going to be made. There is other opportunities in terms of the vouchers, I think, in the ET2 SMEs that you mentioned. And then because there's this general enthusiasm and I guess a willing of the persons to be involved, I think we will have to think about a smart way to actually focus all of this enthusiasm into more concrete action, as you said, not to put like people in front of accomplished actions, let's say. So this is something that we'll probably discuss in the subgroup, because it's probably more efficient, and then come up with an action plan to see how we can foster all of that energy to basically drive the E-TEST in the EMR region. That's about it.
Thanks a lot, Frédéric. It's perfect, and I think it's really the same conclusion that we had with Christophe after discussing 2 hours about the prototype, and then in fact the next steps. But I knew it a little bit in advance, because you will see that for the next step, what I had planned already was really going forwards with our online catalog of technology that is mainly a challenge catalog, not only technology, it's really the challenges. So what we will commit to do before meeting the companies again, is that all the E-TEST partner will hardly work on this catalog to fill much more the information that we have, summary, the state of the art, and to try to estimate which kind of challenge. And then we will come back to the companies, and we will really work with the companies to define clearly the challenges, because we also need the opinion of the companies and we need to really know what you have, the status of your technology, what is possible or not. So for this, and especially for the part challenge, I think this must really be done in collaboration with all of you. Then, you know, we have this ET2SME project under submission that is really focusing on the economic impact of the implementation here in the Euregio Meuse-Rhine. Don't forget that we are still in a preparation phase of the Einstein Telescope. Don't forget where we are on this timeline. So what we are doing now, it's a preparation, a kind of repetition for the big Einstein Telescope. So from very beginning of next year, that's coming really soon, January or February, we will have an official answer from Interreg if our ET2SME project is accepted or not. And it will start on the 1st of March 2021. We will start with the mapping, with the company visit and company fishes, and very specific networking between the SMEs. And we will be able to start with offering and publishing call for vouchers. Vouchers for company to collaborate cross-border and innovate in these challenges requested by the Einstein Telescope. So we are really in the good, we are all in the same timeline. I mean, ETPathfinder, E-TEST and ET2SMEs. And all this has to be finished mid of 2023, because end of 2023 and 24, there will be a big selection and a decision afterwards of the site. So I think we are really in the good timing. And there is don't forget, there is this amount dedicated only to SMEs, financed at 50%. That's something to remind. It's financed by ERDF at 50% for the company. And there will be a very clear procedure to apply to get a voucher. And the sine qua non condition is to have at least one SME, so you need to have the SME status from the extended Euregio Meuse-Rhine. That can work in collaboration with another SMEs, maybe two SMEs, with research centers or a big SMEs, so nobody is excluded. Then, you know it, we have ongoing procurement procedures. There is one for ETPathfinder about vacuum, who is still running. So everybody interested can still apply. It is open until January. And you will have a new one for the E-TEST project open on Monday. For the next one, all the next procurement, it's still not published. So we will really follow your advice. We will be in contact with company also before completely publishing this call for tenders, because I think we need to explore the market before really writing and publishing them. So we have the more chance to get the best offers. And then we really want to organize this kind of event, but maybe not the same, under the same form, in 6 months. So I propose to organize a next industrial advisory board with new content and progress end of May, beginning of June. If it's not a good period for you, please tell me now. Otherwise, I'm planning at that period of time. I hope it's not a too busy period for researchers and for companies. Quoi? It's always busy, but we'll find the best date. So a big
June,
question.
you have a lot of trade shows and other stuff, so I would favor May than June.
Okay. Okay.
In a lot of market, you have trade shows just before the summer holidays, and so they're in June.
Okay. Let's fit in May, because I also think that for all the professors, you have exams maybe in June.
Yes, indeed. But this is also something to be discussed with, the ETPathfinder. So let's discuss together when it fits the best, I think.
Sure,
Yeah.
I will do a doodle.
Mm-hmm.
I will first do a doodle in between the partners, but we will keep in mind maybe May. And for the format, we really openly ask you what's fitting the best. And I really think what I understood is to really have a day, but with smaller groups and focusing on specific technology. We can organize different smaller sessions, and I really hope we can organize it even physically, because this is so important. And so it will be a little bit different of this time. This time was the first one, and on another way, it's also nice to have a common session, because you can have the progress of the whole project. So there will maybe be a very small common session, and then we will separate it, very specific workshops, I say. I got some remarks about Zoom, and I'm very sorry about that. If it's really too problematic for some companies because of the security, I can use other way to organize online meetings. It's not Teams, it's Teams, WebEx. I can, please tell me if it's too problematic, I will skip to another solution. So let's say here, we would say we organize an event in May and maybe very beginning of December. This industrial advisory board will still be led by the two project partners, E-TEST and ETpathfinder. All of these participants are more than welcome, because I think the complete community, the complete ecosystem should be present, because we received a lot of very constructive remarks from everybody. And please go on expressing your interest. We are, the advisory board is really open to any company. So it means maybe new company will come and attend, because we can't give preference to some and not others. So it's really, we are respecting the competitiveness between the companies. And as soon as I have the date for the next one, I will publish it on the website. You know, you will find it in the page industry and also in the news, and you can register and always explain in which field of activity you are working. So, for the next meeting, one important point, there will be a mutual non-disclosure agreement. This is really, really planned. This is already, we are already working on it right now with the legal department of the University of Liège, because you know, University of Liège is the coordinator of E-TEST. And in the name of the E-TEST consortium, we will propose a mutual non-disclosure agreement to all of the companies. And I think that in that case, we can really very freely and go in very high details what we didn't exactly do today. So before closing this meeting, I want to have your last question, remarks, impression, whatever. Please, you can put your micro on. How do you feel after this this morning session?
I think it gave a very good overview.
Thank you. Yes.
Thank you very much, and so glad to hear that you are back alive and kicking from this horrible illness.
Yes,
really,
thanks.
Not a fun thing, I'm sure. No, thanks a lot, because it gives very good idea of the packages of where you're standing, what you expect from where you would like to see participation. And I think from the side of Hamburg Engineering, we haven't been able to involve ourselves so much yet, but we have really one-to-one experience from CERN and also from the EXFEL project in Hamburg, which is the electron laser project in the circular collider, where we did the planning, design, and site supervision. So I hope next time that we can bring in our project manager from that project to give specific input as well. And many thanks for organizing this session. Yeah.
Thanks a lot. Thanks a lot. And please don't hesitate to communicate the information to your colleagues. If you have really, as you say, very appropriate people and very expert people, they can always register on our website, and everything that was said today will be registered, recorded, and we will send it to all of you, and it will be published on our website. You can always come back to us, to the coordination, and also to specific partner. If you want to talk, for instance, with Oliver from Fraunhofer, you just go on the website, you have all the data of all the partners, and you just ask specific question about that, for instance, you know. You are really free to do it.
Aniek,
so, yes?
Could you please share this non-disclosure concept with us all, so we can have a look at it and have our legal departments have a look at it as well before it's official?
Yes, because what it's done right now, I have asked a first version to the legal department. She came back with a proposal, but there were things to adapt to this project in particular and in the way we will collaborate. So I already sent a set of first remarks. She is working on it. I will be working on it with our tech transfer officer, because here at Interface, we are a tech transfer office. And then I will go back to all the I know that we must find a compromise sometimes, and you also have legal departments, and we will ask your opinion before finalizing this form. So before the next meeting, we will have this form ready, and it will be done in as much as we can, of course, because
Thanks.
You know, there must be a compromise sometimes.
Yeah, okay, but it's just like you said, we have to run this through our legal department as well, and
Yes.
they need some time.
They need some time. We know it. It's the same with our legal department, and that's why today I said, okay, no, let's talk quite. We've been into detail, but the company, of course, you won't express everything, and we absolutely know it. And don't worry, it's already planned, and we will come back to you with a template. Yeah, for sure. So.
Yeah, on my side, I would like to thank everyone for participating to this event. So that's really great. So with this large number of participants is a clear evidence that there are many opportunities for industry to collaborate. So thank you very much for all your time and for all the inputs also. And I think that was very fruitful and very helpful for organizing future events. Thank you so much.
Yeah, same on my side. I'd like to extend the thanks to the people in our working group, but to everybody. And I'm sure we'll find ways to focus all this positive energy. Thanks a lot.
So I can't close a meeting without thanking our financiers and our partners. So you know that this E-TEST project is funded by Interreg, Euregio Meuse-Rhine, and by the ERDF funding. And I want to thank all the financiers, because beside of it, Interreg, each of these regions are also funding us and supporting us. So thanks to everybody, and thanks to the 11 partners of this project and of the ETPathfinder project who participate also today. And then, of course, thank to all of you, because this was really a very, very constructive discussion. We've been through quite in detail all the technologies, and we have. I'm very glad that you gave us also very, very constructive remarks to progress and to collaborate better again in the future. And please also find our data. You know that we are the coordination office, and then we spread the information to the researchers. This is our website. Don't hesitate to go and visit it, because a lot of information will be published and updated on the website. And this is the end for me now. So
very well
thanks.
done, Annick. Very well done.
Thank you, and many thanks, Christian, for your very active participation and for the great collaboration we have with Agoria.
Will
Thanks.
grow.
Annick, merci bien de tous que vous avez demandé. C'est une très bonne chance, cohabitation. Oui.
Oh, so that's very nice. Thanks a lot.
This is from the Netherlands.
Yes.
Have a very nice holiday, by the way. Don't forget that.
Yeah, you too, and thank you, El.
And be strong, yes.
Yes, and all of you, you take care.
Stay safe.
Okay.
Bye-bye.
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 Thank you very much. Bye-bye.
Bye-bye.
Bye.
Bye-bye. Bye-bye, everybody.